Well, good evening, good morning, depending on where you are in the world. I'm happy to have everyone here for this event, which is a celebration of the natural history of the Emirates. This is something that's been actually about 6 months in the making. So I'd like to start by thanking the NYU Abu Dhabi Institute, and in particular, Gila and Manal, who've been instrumental in getting us up and online. And we have an exciting lineup of something like 25 different speakers this evening and tomorrow evening, which I'll get into a little bit later, giving us a breadth of the amazing natural history that we have here in the UAE and showing us what a fascinating place it is that we live in. As many of you know, I'm an academic. I work at New York University Abu Dhabi as a biologist with a background in marine ecology, but I actually consider myself a natural historian first and a biologist second. I started my life off in Eastern Canada, where I spent my winters cold camping in the snow, and in the summers on my father's sailboat, sailing along the coast of Nova Scotia, and the fall and autumn seasons out there hiking in the green. But I moved to the UAE almost 25 years ago, and I've enjoyed taking that natural history interest that I had from Canada and growing it over here. So while I've got over 100 publications related to marine systems of the Emirates, I've actually published on things like the insects that dwell in the intermittent streams that we have in the Hajar Mountains on the UAE's east coast. I've published papers on the architecture of canopies of desert trees and various other things. I'm currently writing a paper with Noura Mansouri on the architecture of Jazrat al-Hamra, the historic village in Ras Al Khaimah. So I really do bring a broad interest in natural history to the Emirates from my background. But in coming to the Emirates, I also met some amazing people here who are involved in the Emirates Natural History Group, who I also have to give kudos to as collaborators on this event. So the Emirates Natural History Group has been around since the 1970s. They've been instrumental in supporting us and people like myself meeting others of similar interests and getting out there and enjoying the nature and the splendor that we have here in the Emirates and learning about it. So this is an active group that has regular lectures. It has field trips, and all of these are focused around trying to understand our environment and learn from it. So working at New York University, this background that I had and my interests sort of intersected with the interests of the university, in that we have students from over 150 countries here at NYU Abu Dhabi. I started looking around thinking, well, it'd be really nice to have a course that actually looks outwards at the Emirates so that the students can get out there in the field and try and learn a little bit about their adopted home, this amazing country that we all live in. But I started looking around and I found a couple of books. So we've got The Natural Emirates from the 1990s, and we have this fantastic tome by Peter Hellier and the late Simon Aspinall called The Emirates, A Natural History, both of which were published. Well, the first was published in the early 1990s, the second in the early 2000s. And so, of course, they're a little bit out of date. There's been a lot of research that's been published since then. And there's a lot of other information that's out there, but it's all not consolidated. It's in journal articles and so on. And so what I thought was, well, this would be a fantastic opportunity, given that it's the UAE's 50th birthday this year, to pull a book together. So that's what this event is. It's really a celebration of the UAE's natural history, and we're going to be giving you sneak peeks of the different chapters that are going to form this book that's going to be published late next year, so in preparation for the 51st birthday of the UAE. And so I hope you enjoy what you see tonight. You're going to get a sliver of the information that's going to be available in that book, and we'll send out more information to all the attendees closer to that time, and we'll have a follow-up event in about a year's time from now. So for this event today and tomorrow, it's a two-night event. Today we have 3 sessions. The first is on our physical setting and how the environment structures life. The second, and so that first session has 3 talks, each of 10 minutes. The second session is going to have 4 talks on the UAE's terrestrial and coastal ecosystems. And then the third session tonight has 3 talks, and it's going to focus on the underwater ecosystems of the Emirates, things like coral reefs and seagrass beds and so on. Tomorrow, we're going to be focusing on organisms themselves rather than ecosystems. So your birds, your insects, your various other fauna and flora that associate with the UAE's environment, and learning a bit more about them. And we're going to close with a conversation about the Emirates Natural History Group. So I'd encourage all of you who are interested to go and explore on the web, finding the Emirates Natural History Group for Abu Dhabi or Dubai or Ras Al Khaimah. We have various chapters, and Al Ain, if you're in one of those specific areas. But also to attend tomorrow night's lecture to learn a little bit about the history of the Emirates Natural History Group, which has been around since the 1970s, and where they are today and what they're up to. So with that, I'm going to hand things over to the moderator for the first session, Abdul Rahman Al-Zabi. Abdul Rahman, take it away.
Hello and good evening. Thank you, John. Wonderful intro to a beautiful topic. My name is Abdul Rahman Al-Zabi, as John mentioned. Myself, I'm going to just briefly tell you who I am, an Emirati engineer, but a tour guide as well in Abu Dhabi, our beautiful city. I was happy to grow up both between Abu Dhabi and Ras Al Khaimah. That gave me an opportunity to sort of experience nature back in the 90s, more of a rougher nature where you can see a lot of the animals and insects and stuff like that back then. So today I am super excited and humbled actually to be invited to moderate this session, as well as just to add on what John said, we have 3 speakers coming up on this session for the next hour. As you can see from the agenda, you can read more about them, and you can also find the bios of each speaker on the website link of the event. Each talk will be around 10 minutes. You are welcome to submit questions during the sessions through the chat of this Zoom chat. We will have a Q&A segment at the end of the full hour. At the end of every speaker, at the end of every 3 speakers, sorry. And we will also not be able to answer all questions. However, we'll try to go through the best ones that were submitted. All right. So without further ado, we'll have our first speaker today, Mr. Gary Fulner, chairman of the Dubai Natural History Group. He will talk to us today about the geology and geography of the Emirates. We will be right on in a second.
Good to go, I think.
You got, okay? We have the slides on.
Share screen.
All right, take it away.
And good evening, everybody. Thanks to John Burt. And I'm very pleased to be able to join you for this 50th anniversary celebration. I want to begin by asking you to picture the natural history of the UAE as a stage drama, where all the plants and all the animals, like these many UAE butterflies, and even humans and human culture, play their parts and live out their lives. Viewed that way, the geography and the geology are literally the stage sets for the drama of life. They're the physical background where all the action takes place. And that's the context in which I'll be discussing them tonight. So for the next 9 minutes, more or less, I hope you'll enjoy exploring with me many of the stage sets of the UAE from a naturalist perspective. It's a rewarding exercise because although the UAE is not a physically large country, it has many physical environments that are unusual on a world scale. Let me just preface the rest by saying that I was instructed that this evening is to be a celebration, not a lecture. And so I'm going to try and let the pictures tell most of the story. The geography of a place comprises the different landforms that we see and the associated qualities, characteristics, and climate that go with them. The UAE has 4 primary geographical units, which you can also call environments or ecosystems. They are the sand deserts, shown in yellow, which occupy most of the country, the coastal plain along the Arabian Gulf coast, the mountains, which are in the northeast of the country, running from north to south, and the gravel plains, which flank the mountains. Within each of those units, a number of sub-environments can be distinguished. But what I'm going to do now is to try to briefly illustrate each unit, beginning with the most extensive, the sand deserts. In the south of Abu Dhabi, on the edge of the empty quarter, the landscape that we see is one of huge dune ridges and intervening salt pans, and occasionally picturesque camel trains. As you proceed north towards the coast, the sand becomes more rolling dunes, and then sand plains. In the northeast of the country, towards Ras Al Khaimah, the sands are interrupted by rocky outcrops. And in the east and northeast, it's occasionally punctuated by gaff groves. In most places, the sand desert merges gradually with the coastal plain. Like here in Ras Al Khaimah, this is very near, or Al Quwain, very near the Barracuda, which many of you will know, or here in inland Dubai. But the coastal plain also includes sand beaches, coastal sabkha, vast mudflats, sheltered lagoons. This is an overview of Khor Hulayla from the 20th century. Mangrove forests, and even occasional relief. These are eroded fossil dunes near Jebel Ali. And on the east coast, there are even a number of rocky outcrops. Well, let's go to the mountain environment in the east. There are two main ranges. To the south of Dibba, you have the Hajar Mountains, which are made of red-brown igneous rocks that are collectively called ophiolite. These are extensive, but mostly very difficult to climb. Some areas, however, have more gentle summits, like this in the Olive Highlands. Major wadis in the Hajar Mountains can be quite stark because they're swept periodically or intermittently by floodwaters. Smaller wadis, on the other hand, can be genuine oases of life. And many of them have permanent water. The geology of the Musandam Range, north of Dibba, or a line between Dibba and Kat, is quite different. The Musandam area is basically a thick pile of flat sedimentary rocks. The Musandam has been used for seasonal cultivation for at least hundreds of years, and it includes many remote and picturesque settlements. The gravel plains flank the mountains, and on the east coast, the gravel plains are really equivalent to the coastal plain. The gravel is the outwash from erosion of the mountains over what is now millions of years. The gravel plains often interfinger with the mountains to greater or lesser degrees. And on the inland side, the gravel plains merge with both the desert and the coastal plain. For better or worse, in the modern UAE, the gravel plains are often heavily degraded by infrastructure construction and overgrazing. The geography of a place also includes its global position, which in the case of the UAE is a privileged position. The UAE is located at the junction of the three main biogeographic zones of the old world, the Palearctic in the north, the Afrotropical, and the Oriental. With the result, it receives plant, animal contributions from all those, and human contributions from all those. In fact, of course, today, the UAE receives influences from the entire world. The underlying geology of the UAE is less directly related to the life that it supports at the surface, but geological processes ultimately control the geography, the oceans, and the atmosphere, and so they control life itself. What's on the screen, if it's not obvious to you, is a geological cross-section of the UAE, a very useful tool for understanding the geological structures and interpreting the history. The geology of the UAE is famous for two reasons. One, its huge oil reserves, and two, the ophiolite rocks of the Hajar Mountains. I'm sorry, on my screen, this is partly blocked by pictures. I can't do much about that. As to oil reserves, the UAE's oil reserves have been tremendously important for the development of modern life in the UAE, but they haven't been very significant for the evolution of plant and animal life. So I'll simply mention them in passing. Most of the UAE, as you see in the cross-section, is underlain by relatively undisturbed sedimentary rocks. They were deposited in shallow seas over about the last 550 million years, since the beginning of the Cambrian period. It's in these sedimentary rocks that most of the UAE's oil now sits. The sand dunes that are so prominent are just a superficial overlay. The oil and their host rocks now lie buried deep out of sight. However, the same strata can be seen in the east of the country, where they don't hold any oil, in the Musandam Peninsula. The most dramatic event in the geology of the UAE was the formation of the Hajar Mountains in the east. The rocks of the Hajar Mountains were not originally part of Arabia. Instead, they began as deep ocean rocks from the oceanic crust and mantle in the ocean lying to the east. They were slowly slid on top of Arabia, from the east. They pushed ahead of them some colorful sediments, deep ocean sediments. And in Wadi Kab, you can see the colorful deep ocean sediments slid over the blander sediments of the original Arabian continent. Gradually, Earth forces pushed these new rocks further and further onto Arabia, raised them up, and gradually raised all of Arabia as well, including the UAE. And this is my last slide to make a single mega point. Underlying all of these phenomena is a system of Earth movements called plate tectonics. Plate tectonics shuffles and recycles land masses and ocean basins, and it's a process that's continuing today. It's a major unifying concept for geology. In Arabia, it explains not only things like the opening of the Red Sea and the rise of the Zagros Mountains and the earthquakes that are associated with them, but more broadly, it explains the continuing collision of Afro-Arabia with Eurasia. The ophiolite rocks in the Hajar Mountains are the best exposures of ophiolite, the deep ocean crust and mantle in the world, and they've helped geologists better understand many aspects of plate tectonic processes. In addition, the history of plate tectonic movements also helps us to explain the distribution of plants and animals, not only in the past, but also today. That's the 10-minute tour. Thanks very much.
Much appreciated, Gary. Thank you so much for sharing the great knowledge about the UAE's geology and geography. Personally, I mean, growing up, I knew a bit about the desert and the mountains and so on, but given such details about the specific parts and different types of desert, basically, is really interesting and so certainly insightful. So we move forward to our next speaker, Mr. Francesco Paparella from the New York University Abu Dhabi. He'll be talking to us today about the UAE's climate, the present, the past, and the impact on life. I'm not sure if we can hear you.
Do you hear me?
Yeah, now it's much better. All right, take it away.
Does it work? All right,
yes.
Perfect. So, John and all the organizers for having me here. I'm really honored and happy of discussing with you the climate of the United Arab Emirates. And in order to do so, just let me very briefly introduce how do we as environmental scientists observe and measure climate. We need in order to measure climate, we need to take a very large number of measurements throughout the planet, repeated constantly as much as possible for very long times. The typical time frame within which we can speak of climate is conventionally 30 years. You can do a little bit less, but that is the order of magnitude for being able to talk about climate patterns per se. And these days we have a very large number of tools, land-based, aircraft-based, ship satellites that are extremely important satellites that observe the Earth for us. But just data are not enough, because data essentially refer to single locations and are scattered. If you just gather together all the data, you have something that may look like this set of green points, a cloud of data points that may not...
Francesco, just to interrupt you, you're not sharing a screen. We can't see any screen.
I'm sorry, I thought I was sharing the screen. Do you see it now?
Yes.
Apologies. I thought I was sharing my screen. All right, so anyhow, so if you just have a cloud of data, this is not enough to generally show a clear pattern or a clear trend. And therefore, what we need to do is to interpolate data, but not just with any interpolator. We need something that is physically consistent. We do not want to violate the laws of dynamics or of thermodynamics. And therefore, what is needed is to use models that are very close to the models that are generally used for meteor forecasts, modified in such a way that they act as data interpolators. And this process is called making a reanalysis of the data. And all that I will do in this short conversation is showing you what is the climate of the Emirates in the last 40 years, according to the ERA 5-year analysis, which are the most modern and up-to-date reanalysis that are available today. Let me start with wind speed. So here I'm plotting the average wind speed in the last 41 years. In the upper left panel refers to the meteorological winter, December, January, February. And then we have the meteorological spring, May, April, and March, April, and May. the summer and the autumn. We can immediately perceive that spring is slightly more windy than the other seasons, and the fall is slightly less windy than the other seasons. There is less wind on the mountains just because this refers to the wind that can be measured at 10 meters of height. Therefore, the orography would shelter most of the wind. And we also perceive that the coastline is breezier than the interior, as can be easily expected. And let's have a look at trends. 40 years, as I said, is enough to be, is a time span long enough to allow us to talk about climatic trends. And in the left panel, I'm plotting the the summer mean wind speed in the decade that goes from 1979 to 1988. On the right panel, I do the same for the decade, the last decade between 2011 and 2020. And the pattern is essentially the same. There is no significant difference between these two plots. So this means that in the last 40 years, there have not been substantial changes in the average wind speed in summer. If we go to precipitation, however, the story is a bit different. This again is the average monthly precipitation in millimeters for the 4 seasons. And immediately we see that the rainiest season is winter. Spring also has some rain on the mountains, while summer and autumn essentially have no rain, just a tiny bit on the mountains, but it's really negligible. The Musandam Peninsula and the mountains are the rainiest place in this country. Not surprising because they are directly involved in the weather system that comes from the Arabian Sea. It's quite curious that the summer monsoon doesn't really produce any substantial precipitation in this region. If we go and look at the trends, we will start seeing the first important climatological trend of the last 40 years. You immediately see that in winter, 40 years ago, it rained essentially twice as much as what it rains today, say in the last 10 years. And at every point in this chart, recently, it rained something like 5 millimeters per month less than what it used to rain 40 years ago. The Musandam Peninsula still remains the rainiest place, but even there, the amount of rainfall has decreased measurably, appreciably. This is, in some sense, quite surprising. And these are data. As I said, this is just a model interpolation of observed data. This is quite surprising because the consensus is that in the future, because of climate change, we should see an increase in precipitation in this region. This is the very latest data from IPCC. These in particular are an average of 32 models from CMIP6, which is a set of model simulation commissioned by IPCC for their last report, which is essentially out already. It's still out in draft form. And this comes from a website that is public. If you just type IPCC Interactive Atlas, it just lands on this website. And you can play with this. This is a moderate scenario in which some warming occurred, but not too much. And these green areas are areas with increased precipitation up to 50% more than today's levels. The Eastern Arabian region is clearly a region of increased precipitation. However, it has to be said that these projections do not agree with each other. In these models, some actually see less precipitation and some see more precipitation. Therefore, there is a large uncertainty in what the future trends in this region for precipitation may be. There's no uncertainty about the temperature trends, but there is uncertainty for the precipitation trends. And so I mentioned temperature. Let's just move on to temperature. the first two panels on top are the daily minima and maxima in January. No surprises here. It's fairly warm even in January, warmer in the interior and less warm along the coastline. And the lower panels show the minima, the daily minima and daily maxima in July on average in the last 40 years. And again, no surprises, in the desert, it's much hotter than along the coastline. The trends show the very same pattern 40 years ago and 10 years ago, in the last 10 years. But it's, if you can read the numbers on the labels, well, there is 1 degree of change. In 40 years, there has been a 1 degree increase in the July average maximum temperature. Now, let me conclude just by mentioning that temperature, air temperature, is not the only parameter that determines, let's say, the well-being of somebody exposed to the environment. We all know that if there is a breeze, if there is some wind that blows on our face, on our skin, we feel cooler. And the reason because that happens is because there is water that evaporates out of our skin. And this evaporative process produces, takes away energy, essentially, and produces cooling. This process is also exploited in the wind catcher towers that are a staple of the local architecture. And I should mention that when these structures were really used, on these wooden poles, there were damp cloths in order to exploit the evaporative cooling effect. It is really the evaporation of water that cools the air, and not just the mechanical movement of air. So this idea that evaporation cools is quantified into a specific quantity, which is called wet bulb temperature. Ideally, that is the temperature that the thermometer whose bulb has been wetted, and then there is air blown on the bulb, would measure, would show. And that is always less than the air temperature proper because of evaporative cooling. In practice, what does it mean? Wet bulb temperature is the lowest possible temperature that you can attain by purely passive means. So imagine, for example, you are under a tent out in the desert, so in the shade, and there is ample breeze, a very sustained breeze under your tent. You would feel the wet bulb temperature rather than air temperature proper. There is a physiological
Mr.
importance.
Francisco, I just wanted to give you the last bit of your conclusion, if you don't mind.
Yes,
yes. We'll move on to the next.
I'm done. So my final point is that there is a physiological threshold, which is 35 degrees. And right now, even in August on the coastline, we reach 29 degrees, which is fairly removed yet from the physiological threshold. And in the trend, we see that 40 years ago, there was 1 degree less in the wet bulb temperature, just as in the air temperature. But the conclusions are that the hot desert climate is, well, becoming hotter and more arid, although the future projections say otherwise, suggest that this trend may be reversed, and that passive evaporative cooling technologies still have room to work. They still work in this environment. And this is it. Thank you.
Much appreciated, Francesco, on this very enlightening talk. You know, we obviously, as Emiratis, we have noticed the change in rain trends throughout the years. So let's hope some of the findings prove beneficial. So our next speaker, obviously, is no stranger, Mr. John Burt, New York University, a professor, and he will talk to us today about the marine environments of the Emirates.
Thank you very much, Abdul Rahman. So I'm going to put on my timer here. So going back to something Gary ended his talk with, I'd like to start at the Arabian Plate. So we're actually sitting on the world's smallest tectonic plate and sliding over towards the Eurasian Plate, moving about 2 centimeters a year. So it doesn't seem like a lot, but that's what's giving us those mountains and the sort of geography of this region. And this geography that we have for this region, these mountain ranges really do influence the marine environments that we have around our coastline, which I'll be focusing on today. So you may or may not know this, but the Arabian Gulf, or the Persian Gulf as it's also known, is incredibly shallow as a fairly large sea. And this is in contrast to what we get in the Gulf of Oman. So the Gulf of Oman actually goes down to something like 3 kilometers depth. And in the nearshore areas of the UAE, will go down to about 500 meters depth. In contrast, when you look at the Arabian Gulf, you're looking at a system that at maximum is 90 meters depth. And for the vast majority of it is less than 15, 20 meters depth. The average depth of the Gulf is only 30 meters. And so these two very divergent bathymetries really give us 2 distinct environments. In the Gulf of Oman, we have very sort of normal oceanic system over there, while in the Arabian Gulf, we have a system that is much more constrained by this depth and therefore has a lot of volatility in terms of its environmental conditions. The Gulf is also interesting in that it's quite young. So as you can see here, we've got some time scales going through time since the last glacial period. So when the last ice age started finishing up and the ice sheets were melting, you can see this intrusion of water, because at that time, sea levels were around 120 meters below what we are today. And of course, the Gulf being at maximum 90 meters, there was no Gulf. It was just sand at that point. A little more humid, so think of it as grasslands. And so as those ice sheets melted and water started to rise around the world, you can see it regressing into the Gulf, called the Great Transgression, and giving us the modern coastlines that we have today of around just 6,000 years ago. So this is really quite a young system we have on the Gulf Coast of the UAE, whereas the oceanic system on the East Coast is quite ancient by comparison. And this is important biologically when you think of evolution and adaptation and so on. In terms of the sedimentary sort of area we have in the southern basin of the Gulf, it's largely covered by sands and muds, for the most part, extending almost all the way over towards Iran. There where you start to get into really fine muds because of the depth, basically. On the east coast of the UAE, you have these rocky outcrops that Gary was showing in his images earlier, but that actually cascades very quickly down to very deep depths. And so we have a very limited coastline along the coast of the east coast of the UAE for organisms to actually colonize because of that rapid shift in depth, with it cascading down as sort of rocky escarpments surrounded by sands and fine muds. These sandy areas that we see in the southern basin of the Gulf, largely along Dubai and Abu Dhabi and the surrounding areas, actually is sitting on top of our hard ground. So there's this rocky sedimentary rock that Gary was referring to earlier, that basically goes all the way out to the border of the UAE with Iran. And this rock that you get in this area is really interesting. In the surface sediments where we've got sands, because of the high salinity of the Gulf, which I'll talk about in a moment, the temperatures here and the other environmental conditions, we actually get it super saturated with aragonite, and that aragonite can actually form sort of a cement that binds sand grains together, which you can see in these images here. And what you end up with as a result of that, so if you have a period of 2 to 3 days where you've got light winds, so the sand's not moving around, they'll actually start to form these crystals and make what we call cap rock. And so you can see this underwater cap rock here, and that's really important because things like algae, corals, and other organisms that require hard bottom habitat to grow can only occur in these habitats. So you'll see these occasionally erupting out of the sea bottom throughout the southern basin of the Gulf. On the East Coast, we're not really worried about that because we've got the rocky outcrops of the Hajar Mountains that actually plunge into the sea, and that's where you'll get your coral growth. You will not see any coral growth or large macroalgal stands on the sandy areas of the East Coast either. So what's going on in terms of our currents? We've got a really unusual directionality to our currents here. So you can see they come in from the Gulf of Oman, move along the coast of Iran up towards Kuwait, and then circle around and come down again. What's actually going on there is that these large scale processes are being driven by changes in salinity that happen as a result of evaporation. And so you can see from this graphic that the water's coming in at around 36 parts per thousand, or PSU as it's also known. And as it goes along, we're in an environment that's obviously very hot, particularly in summer. It's dry all year round and there's no freshwater input. And so we have evaporation occurring as this water is migrating into the Gulf. So it's getting saltier and saltier and saltier as it moves up along the coast of Iran as sort of fresh seawater becoming saltier and saltier. But of course, with changes in salinity, you get changes in density. And so at some point it starts to sink, and that water sinks down to the bottom and then glides along the bottom following the gradient of the bathymetry back under the coast, towards the coast of Iran, underneath the freshwater and back out into the Strait of Hormuz. And this is significant. The water is typically moving at about 10 to 20 centimeters per second at the Strait of Hormuz. So it's basically a river-like current that comes in through the Strait of Hormuz, entirely driven by this salinity change, and it's moving against the predominant winds here. So it's really significant in terms of the marine environment that we have along the coast of the UAE. And the reason for that is once it circles around the Gulf, so it starts off at 36, goes up to 38 along the coast of Iran. Once it gets up by Kuwait and Saudi, you can see it increasing to 40. And by the time it circulates back down towards the coastline of the UAE, it can reach upwards. So the reefs that I normally dive on are around 44 parts per thousand. And you can see in actuality that in the lagoonal areas, it goes in excess of 50 parts per thousand. So that's really incredibly high salinity for organisms to have to cope with. We're not just a super salty environment along the Gulf Coast of the UAE, we're also an unusual thermal environment. So this is a graphic showing you sea surface temperatures throughout the Indian Ocean in the summer of 2017. And what you can see zooming in is that the UAE actually is bordered by the world's hottest sea, the Arabian Gulf, every single summer. So water temperatures here will regularly reach up to 36 degrees Celsius. Now, not as high over on the East Coast, again, because it's much, much deeper there. So the temperatures are much more constrained. And we do see this in the variability of temperatures through the year as well. So a lot of the focus of people talking about the water temperatures here is on the summer, but it actually gets incredibly cold for tropical organisms in the wintertime as well. So it'll hit 36, the same temperature as your blood in the summer, dropping down to the mid to high teens in the wintertime. Incredibly stressful for tropical organisms that live here, like mangroves, seagrasses, and so on, corals. Our winds here are structured by the regional terrain. You can see here the Zagros Mountains and the Hajar Mountains. Those basically funnel winds that are coming from the Mediterranean across the Gulf, giving us what we call the Shamal winds. Shamal is Arabic for north. And so it forces, those mountain ranges force the winds across the Gulf, giving us our northerly winds that are so common here. And you can see here, looking at a couple of different places, going from Abu Dhabi here, you can see both in January and in August, the wind almost always is coming from the north-northwest. That's those Shamal winds. But as you go up towards Ras Al Khaimah and then over to Fujairah, you can see that things change. In Fujairah in particular, you'll notice it's normally coming from the north in the wintertime, following that pattern that we just talked about. But in the summertime, it completely shifts directions. And that's because we have the influence of the monsoon there. And you can see echoes of this over here in Ras Al Khaimah, where it's got some northerly winds because of the Shamal and some southerly winds because of the monsoon. And obviously in January, Ras Al Khaimah is a bit of a mess in terms of its winds, and that's because it's so close to the mountain areas there. So you get a lot of vortexes. These winds can lead to things called whitening, where the water is so shallow in the Southern Gulf that it's actually stirring up the bottom, leading to turbidity, which is a stressor for many marine organisms. These winter Shamal winds can actually cool down waters. And so you can see a graphic over here showing water that's incredibly hot in early November. A Shamal wind starts and moves its way down the Gulf. You can see the temperatures are cooling, leading to differences of 2 to 4 degrees Celsius in the temperature of water in winter. This can lead to things like in wintertime, if you've got a strong Shamal, it can actually lead to bleaching events in corals. So these are pictures of corals that are bleached. In 1964, we had air temperatures go down to just above freezing. The sea surface temperature reached 4 degrees Celsius and the bottom temperatures went down to 14 degrees Celsius. So it can get incredibly cold because of these winter winds. Summer winds are also important. They can lead to things like these giant eddies you see forming off of the coast of Iran, which is important for pumping the larvae of things like fishes and corals from the very extensive reefs in Iran over to the UAE, supporting our reefs. They can also lead to cooling in the summertime as well. And this is incredibly important, as Francesca was talking about. You can see here going from August to early September to mid-September to late September, the influence of Shamal winds on causing a cooling of temperatures in our seas. And that can be important because if you don't have strong winds in summertime, you get things like this. So this is corals undergoing bleaching because of extreme temperatures. So this is after a period of winds. What happened in the summer of 2017, where we had 5 weeks with very light breeze winds and no small winds. This is an incredibly devastating bleaching event that happened on the reefs of the UAE. And just this year, because we again had 3 weeks with no winds, we had mass mortalities of turtles, unfortunately, in the western region of Abu Dhabi. I personally counted over 120, and these are an endangered species. And it's also led to mass bleaching on the UAE's east coast and die-offs of these table corals, which is something unprecedented for the reefs of the UAE. And I'm just going to skip the primary productivity and basically just close by saying that these divergent environments that we have across the Emirates are important because they're basically driving the ecology of all these marine systems that we have along our coastlines and in our seas. And so I just like people to reflect on the extremity of the environment and give kudos to the organisms that live here. Thank you very much.
Thank you, John, for a great presentation. Obviously, you know, the UAE's environment is not only critical for the general geography of the region, but it's also very sensitive, as you mentioned. So the coral bleaching is something, you know, people have to consider, especially fishermen and other people that benefit from this from the industry here in the UAE. So moving on, we'll go to the Q&A of this session. So for all our 3 speakers, people sent in some questions, and we are also welcoming questions from now or starting now. So I'll direct the question to the different speakers that we received. We'll start with Gary Fulner. We got a question regarding the geology and geography of the UAE. So the question that we got was, how has the UAE always been a desert country?
The answer there is yes, but the UAE hasn't. Let's go back 25 to 30 million years, because that's when the UAE was first emergent as land rather than water. At that time, and from that time to the present, the UAE has generally been wetter than it is now, but it has never been tropical wet. It's the climate for most of that time will have been more like a seasonal Mediterranean or East African kind of climate. How do we know that? We know that partly because of the coarse sediment that has eroded the mountains over that time. If you go down, you can find under Dubai and under Abu Dhabi, you can find relatively coarse gravels washed out of the mountains. That doesn't happen in a climate like today's rainfall. Moving forward quite a bit to just the last 2 million years or 1.5 million years of the ice ages, the climate has fluctuated greatly. If you go back to just after the last ice age, we had in the 11 to 17,000 years, not million, but thousand, really just before human habitation here, at an extremely dry period. And under the Emirates and under you can, when people construct buildings in Dubai, you can go into thick dune sands as part of the foundation. But since that time, things got a little wetter from about 11,000 to 6,000, and at about 5,000 or 6,000 to present, we settled into today's conditions, which are not hyper-arid, but arid. except in the mountain regions. So mostly it's never been very wet, mostly been a little wetter than today.
Interesting. Thank you so much. We have a question directed to Francesco. The question asks maybe briefly, what can these climatic changes tell us about desertification in the UAE?
Well, the UAE is mostly already desert, and therefore is already desertified. What is really interesting is the potential for agriculture, in the sense that heat is a limiting factor for plants if it's extreme, but the really important limiting factor is water. So the real question is, how much, if we can tap into a source of water, for example, from desalination, can we still do agriculture? And the answer is that there is still a potential. And so, for example, if you just pop out to Google Maps and you look from the satellite picture, you will see crop circles close to Dubai. And because even though it's really hot, if it's possible to gather water, then there is the potential for agriculture. So the question of desertification really is a question on land management. And it has been very well documented in many, many places, in Africa, in the US, even a phenomenon like the Dust Bowl in the US in the 1920s and 30s. That really was more a fact due to mismanagement of the land than a real climatic shift. So in terms, if we want to talk about desertification, it's really about the management of the land.
Well, yeah, interesting. That will be maybe a more of a serious effect on it than climatic changes. But or yeah. But thank you for sharing your answer. I think John will join a later session to answer your questions. So if you have any questions, please still direct your questions to John on the Q&A section of this Zoom call, and we will answer them later on. I want to thank our speakers for today and the first session, as we will move on to the next session with my colleague Amal Al-Gargawi. She'll take it on from here. It was great having you all. Thank you.
Assalamualaikum everyone. Thank you, Abdurrahman, and thank you to the speakers for kicking off our first session of the day. My name is Amal Al-Gargawi, and I'll be your second moderator. I am an NYU Abu Dhabi alumna. I pursued a bachelor's in social research and public policy with a concentration in economics. Recently completed my postgraduate degrees at Oxford, and January onwards, I'll be working with John on areas related to the intersection of science and policy in the UAE. Thrilled to be here, honored to be a moderator, of course. This second session will be on the UAE's terrestrial and coastal ecosystems. It'll be split into 4 segments. Within the first segment, we'll have Gary Brown, who's an environmental consultant, and Gary Fulner, who you've seen in the previous session, the chairman of the Dubai Natural History Group, discussing the desert, mountains, and gravel plains within the Emirates. This will be a 20-minute section. This will be followed by Stephen Lokier, who will elaborate on the Sabkha ecosystems. Stephen is a senior lecturer at the University of Derby. And within the third segment, we have Guillermo Fries, who's postdoctoral research at NYU Abu Dhabi, and he will be speaking on mangrove forests. Last but not least, Daniel Mateos Molina from the Emirates Nature Worldwide Fund will be examining coastal lagoons. And this will be concluded with a Q&A session, of course, as is common. And feel free to submit your questions in between the sessions. Of course, that said, if Gary Brown and Gary Fulner, if you may please share your screens.
Mike?
Go ahead, Gary, you can start share. Oh, we see it now.
Okay, I'm sorry to, thank you, Amal. I'm sorry to disappoint any fans of Gary Brown, but Gary Brown will not be on screen today, although he's contributed to the presentation. Terrestrial ecosystems give us a lot of ground to cover, so I'm going to jump right in. It should be no surprise that the four main terrestrial ecosystems coincide with the four main geographical units that I introduced earlier: the coastal plain, the sand deserts, the mountains, and the gravel plains. The aim of this section is to explore with you in modest detail the sands, the mountains, and the gravel plains, and in particular to illustrate some of the floral and faunal highlights and other factors that make each of those units and their subunits distinctive. This more detailed habitat map prepared by Gary Brown shows at least 6 major subdivisions for the sand units of the UAE. In the east and the northeast, the deserts are relatively well vegetated. Among the rolling dunes and flats, the gaff tree and the calotropis shrub are nearly ubiquitous. Both of these plants have exceptionally deep roots that allow them to reach subsurface water that other plants can't. Subsurface water is more common nearest the mountains because that's where the runoff comes from. And so you do lose both of these species as you go further west and south in the UAE. 2 smaller shrubs that are even more widespread are typically found in low-lying flats, almost always with a small sand cover, and they often form monospecific, that is single species flats. The one shown here is zygophyllum, which is characterized by its bead-like leaves. A second species, haloxylon, mimics the gross appearance, but when you look at it, you see that the leaves are stringy. Zygophyllum, the first one with the beads, extends all the way south and on into the empty quarter. This haloxylon, the local name Rhynth, is more limited to coastal and intermediate areas. Desert annuals can be locally abundant after rain, and rain in the desert can be extremely localized. One of the most common annuals and best known is this Nerata procumbens. Most people who've been out in the desert will recognize this spiky seed capsule, which many people find it hard to forget. A photo like this from what I call the intermediate desert near Naho is a reminder that almost all areas of the UAE desert, and in fact, almost all areas of the UAE, have been relatively heavily grazed over the past 4 decades at least. And we need to take this into account in assessing the flora that we see today. In spite of that, areas like this have maintained their own distinctive fauna as well as flora. This striped fringe-toed lizard, Acanthodactylus gangrorhynchatus, from it's found from Swayhan to Jebel Ali only. It's distinct from this white-spotted fringe-toed lizard, which is found over most of the UAE desert except the deepest sands in the south. Not only lizards, but birds change as you move inland, go through the intermediate deserts into the deep deserts of the south. But we'll have a separate presentation on birds, so I'll skip that. What is the vegetation doing as you move inland a little more? This sedge, Cyperus conglomeratus, is dominant in many areas. One reason for its success is that it's not eaten by grazers. The second reason is that it does much better than most other plants at keeping its head and body above the windswept mobile sand. In the extreme south, in the Liwa area and the Manadir area in the southeast, we have the landscape of huge dune ridges and intervening sabkha pans. This photo shows a good profile of the dunes, the steep slip face of a mega dune ridge, but at the bottom there's accumulated a wedge of sand that where the water that percolates through the dunes eventually winds up. And so this wedge of sand on the north edge of the pan, the south edge of the dune, is a place where you can see more vegetation, including the zygophyllum that we saw, but also less common plants like this dipterygium, which has just become cleoma, and this spiky cornulaca. These areas, that's those sand wedges, are also good places to find cute, furry, small mammals, gerbils, and desert hares. But there are also places to find things you're probably less eager to see, like scorpions, of which there are a number in the desert. In wet years, like the mid-90s, which were exceptionally wet on an 80-year time scale, the desert can be extremely green, although most of the plants you see here are zygophyllum. When conditions are good, it's a special treat to see the huge flowering tribulus, even in the deep desert. But the desert isn't always so pretty, and the plants that live there have to simply be ready to take it, whatever comes along. Dune layers can sometimes be cemented by rainwater and compression. Wind erosion exposes what I call fossil dunes, and these hard substrates are a favorite home to the UAE's spiny-tailed lizard, the dove. The dove isn't the only specialized lizard in our sand deserts. There are several others. They include at least 2 toad-headed agamas. This is the one that's more common on hard substrates. The other one prefers softer sand. Monitor lizards are also found throughout the UAE and in the deep desert, but at least in the deep desert, you mostly see their tracks, only rarely the individuals, and it's hard to get close enough to get a photo. The sabkha flats between the dune ridges are essentially barren, even though the water table is fairly close to the surface. These areas can flood to as much as 30 meters or more. They'll stay wet for weeks or maybe a month. When they dry, they leave a crust of salt, dazzling but temporary. Well, the clock is running, so let's move on immediately to the mountains in the east. The best way to understand the mountains of the UAE as an ecosystem, maybe the previous picture is better, is to think of them as a coral reef in an ocean, but in this case, an ocean of sand. The number of animals and plants that you can expect to see in a day in the mountains is far greater than what you could expect in the desert. Our relatively small mountain area is home to approximately 50% or more of the UAE's native plants. That's for 2 main reasons. One, the climate is more moderate overall in terms of temperature, moisture, and shelter in the mountains than it is in the open desert. And second, the mountains provide a greater degree of diversity of microhabitats. Before we explore that variety, however, I want to make what I think is an important point, which is to emphasize the uniqueness of the Hajar Mountains as a whole in a global and regional context. I'm going to do that by highlighting just a sample of the plants and animals that are either unique to or localized in the Hajar Mountains. Most of you will probably recognize this cactus-like plant, Caralluma arabica. Probably fewer of you will recognize this higher elevation Pulicaria edmondsonii and the spiny Echinops erinaceus, which is at home in coarse rubble. My personal favorite is this Rumex lemoniastrum, which was rediscovered in the 90s after about 150 years. All of the plants I've just showed you are essentially Hajar Mountain endemics, but only this last one is actually rare in the UAE. Being endemic doesn't necessarily mean being rare. Among vertebrate animals, we now know that many Hajar Mountain reptiles are distinct from even very similar looking species in neighboring areas. So in recent years, we've added some endemics to our list. Endemics that were well known include this large Oman, so-called Oman lizard, and its smaller relative, the blue-tailed lizard. We've more recently learned that our blue rock agama is actually a distinct species for the Hajar Mountains. And a number of our geckos, both diurnal geckos and nocturnal geckos, are turning out to be endemic to the Hajar Mountains. That's as a result of DNA work that's been done in recent years by, especially by teams from Spain and from other researchers collaborating here in the UAE. Our common wadi fish, Garabaramiae, is now known to be native to the UAE and only the northernmost portion of the mountains in Oman. Beyond Muscat, it's replaced by other Gara species. We have no endemic birds in the UAE, but we have a number of birds that are restricted to mountain areas. I'm going to show just one of my favorites, which is the Eurasian cuckoo that migrates through each spring, and in a wet year, they can the mountain regions can resound with the calls of cuckoo, especially the Masandam area. For vertebrates, or mammals rather, the most significant Hajar endemic is the Arabian tahr. This one happens to be an adolescent male that ran across hiking in the mountains. We didn't disturb it or determine the cause of death, probably a fall. Sadly, the Arabian leopard is now gone from the Hajar Mountains, in part because it was a victim of persecution. How about invertebrates? We have our own Hajar Mountain damselfly and a more widespread but very rare dragonfly is now known to be, the Hajar Mountains is now known to be a hotspot for it. So we're world famous on that score as well. There are several butterflies which are present in Arabia only in the Hajar Mountains. This is Lowe's blue, which is normally found in colder countries to the north. And this is a skipper, the Arabian grizzled skipper, that's found in a spot in the UAE, a spot in northern Oman, and otherwise only in Yemen and Somalia. And we have an attractive little jumping spider, which is common in the mountains, but which the work of Tony Van Harten has established as being a species found so far only in the UAE, although it probably extends through the Hajar. Well, why is there so much diversity in the mountains? Let's take a look at just a couple of the reasons. One obvious one is geology. And this map shows you the two geological distinctions I mentioned earlier: the sedimentary, flat sedimentary rocks of the Mosandum area and the difficult brown ophiolite rocks of the Hajar Mountains. The geology can control the relative abundance of the plant species that you see. I'm going to show you just two extreme examples. This very pretty Astragalus fasciculifolius is essentially found only in the Mosandum Peninsula. It more or less avoids the ophiolite. And on the other hand, this somewhat spiky Convolvulus virgatus is very common in the Hajar Mountains, but especially in the mantle rocks, and it's much less common in the other environments, the crustal rocks and the sediments of the Mosandum. Other plants react to varying degrees. More important than geology, though, for the plant distribution is probably the basic factors of habitat and elevation. And we can see this in a simple way by comparing wadis, slopes, and summit areas. Many wadis look pretty barren, and main wadis are, because they're frequently flushed by, or not frequently, but intermittently flushed by floods. In the wadi environment, the most common plant is this Tephrosia apollinea, which is popular with butterflies, but the quadrupeds don't eat it, giving it a big advantage. On the other hand, tributary wadis, especially after rain, can be flush with both annuals and perennials taking advantage of the good conditions. Occasionally you'll see a vast stand of an annual or perennial that's just taken off. This is a big stand of Physarinthus in silt accumulated behind a dam on the East Coast. A number of species limit themselves primarily to rocky slopes. A couple of conspicuous examples are the drumstick tree, Moringa peregrina, this rather regular geometric Lucas inflata, mint family, and the zigzag daisy, Lonea bourmuleri. As to summit areas, the Hajar Mountains of the UAE are actually the lowest area in the entire Hajar Mountain chain. The summits are generally at 900 to 1,000 meters, but they're particularly steep and barren. Very few plants make their home there. One that does is this Phagnolon schweinfurthii, which for its own reasons does pretty well in that environment.
Apologies, Gary. I think you're at 20 minutes.
Okay, let me just get, can I get through the summit areas? And I'll close with that. A few summit areas are more accommodating. In the Gabbro units are home to the wild olive and a couple of other smaller shrubs and also annuals. In the Rus al Jabal, the summits are relatively flat and they top out at about 1,500 meters, but there's a big change in the plants at the 1,000-meter marker. The high areas are characterized by the convolvulus, by the aromatic sagebrush, and by the wild almond, which is the main tree in the Mosandum. At the highest elevations here on top of, or near the top of Jebel Yais, the almonds are stunted, and there's a lookalike plant of a different species that extends in high mountains all the way to the Karakoram in northern Pakistan. I've also seen in years past caracal up in that area, and also the relatively rare Persian horn viper. And I think that's the gravel plains, treed in the north, heavily disturbed by infrastructure construction, grazing in the south. The plant that you see is Razzia stricta, is the only ground cover there. There are a couple of endemic lizards. One is rare on the edge of its global range. Another is much more common throughout South Arabia. And you can also see here in this last slide, the two widespread UAE land snails, which you can find not only in the mountain environments, but also in suburban backyards. Thank you very much. Sorry to run over a little bit. Apologies, Amal.
Not at all. Wonderful talk, Gary. I think it's very timely with people flocking to the desert and mountains in the winters. Gives us a greater appreciation of our natural flora and fauna. But without further ado, we can move on to Stephen Lokier, the senior lecturer at the University of Derby. Whenever you're ready, Stephen.
Absolutely. Right. Okay. Can I just check that you can hear me okay?
Yes.
Grand. Brilliant. Okay, everybody. Welcome. I'm going to be taking you on a bit of a tour. We're going to be doing a little bit of a tour of the Sabkha, and we will be seeing some life, but it's sort of not life as you may know it. What we're going to be doing is mainly looking at the geoscience of the area and why this has been important. This is a celebration. This is a celebration of the UAE. And one of the things we should be celebrating is most definitely the Sabkha. Sabkhas are amazing places and they're absolutely unique. The UAE is perhaps the most studied, the Abu Dhabi Sabkha is the most studied Sabkha on the planet today. And I'll tell you all about those systems. So where are we? You all know where we are. So we're over here in the Arabian Gulf. We're down on the southern shore of the Arabian Gulf. And we've been conducting studies on the southern shore for close on 20 years, in fact, just over 20 years, mainly during my time at Khalifa University, or the Petroleum Institute as it was until recently. And I'm continuing that study with a range of collaborators from a number of universities, including, of course, Khalifa University. And this is what the Sabkha looks like on a satellite image. So in this image, the north, the top of this image is the marine environment, the sea, and the land is to the south. The Sabkha basically means salt flat, flat, muddy, salty, very flat. Let's try and bring that home. First of all, why are we looking at it? Well, we're looking at it for the simple reason that it offers the absolute perfect environment to study something that we can't see or we can't understand from the ancient geological record. The ancient geological record has many rocks that were deposited when sea levels were high and the sea was flooding onto the land. The sea was flooding onto the continents. I want you to imagine sea levels 30, 40 meters maybe higher than today, even higher than that, flooding onto the continents. And that created environments that were very similar to the Arabian Gulf today. And we can go to the Arabian Gulf and we can make shallow holes into the ground and have a look what's happening in the subsurface. We can measure environmental data at the surface. We can perform geochemistry. We can use our SEMs to look at our hard grounds and our cements. These are rather like the cements that were referred to earlier with the hard grounds. So it's very useful. But why is it useful? Well, it's useful because we need data. We need data if we're going to understand paleo environments, ancient environments. What were the environments like back in the geological history? We want to understand how those environments evolved. And we want to understand how they evolved, not just in the surface, at the Earth's surface, but how they evolved when they got buried and got deeper and deeper. What stresses did they go through? And this all has an application. This has applications in terms of our search for hydrocarbons, for oil and gas, but also for the future as we move through the energy transition. These same rules, the same parameters that allow us to look for hydrocarbons, for oil and gas, are going to allow us to inject carbon dioxide into the surface, what we call CCS, or to store hydrogen in the surface, or to look for water. The principles are very, very similar, and in fact, for geothermal energy. So let me introduce you to the SABCA. We're going to be doing a bit of a tour. We'll start up here, down here in the supratidal zone, what I call the storm surge zone. Then we're going to move through the microbial mat belt and into the middle intertidal zone. And eventually we'll actually move offshore and have a little look into the marine environment. And we'll be working our way from landward to seaward, following the arrows that I'm showing in that diagram there. So to start with, the SABCA is low angle. It is flat. It is flat beyond belief. Here's our unit, the standard international unit of flatness, a pancake. And a pancake has a flattening ratio of 0.957. The flattening ratio of the SABCA is 0.9986. It's flatter than a pancake. One would be absolutely horizontal. The angle of slope in the SABCA is 0.07 to 0.08 degrees. If this was a billiard or pool table, if you're playing pool, you would put a ball on this table and it would not roll. That's how flat it is. We've had already an introduction to our climate, so I won't spend too long on this, but what I want you to understand is that rainfall is very low compared to evaporation. Evaporation is orders of magnitude higher than our rainfall. And we have also a strong variance in temperature between day and night and summer and winter. So let's start the tour. The first of the locations we're going to visit is up here in the supratidal SABCA. What we mean by supratidal means it doesn't get flooded by the sea. This area never gets flooded by the sea. And that's what the supratidal looks like. In fact, I noticed that the human that's for scale is actually in our audience. That's Dr. Thomas Stoiber there in the distance from Khalifa University. And he's offering us a little scale there. And it shows you how flat that surface is. And that surface is covered in a halite crust, a thin crust of halite, common salt, like the salt you put on your fish and chips, covering that surface and holding that surface down. And as that salt grows, it will quite often produce these beautiful halite polygons, these beautiful polygonal textures covering the whole of the SABCA surface. But these textures are very ephemeral. They don't last very long. As soon as we have some rainfall, or maybe even a few humid nights, they will dissolve. And so while we see them in the modern SABCA, and they're very common in the modern SABCA, those surface halites, those halite crusts, I'm afraid we never really see preserved into the geologic record. But if we dig a hole through those halite crusts and we excavate into the subsurface, then we find this kind of profile. And here we see this mineral here, anhydrite, very important mineral in SABCA. But the dominant mineral is this one you can see through here. This is gypsum. It's calcium sulfate, CaSO4, calcium sulfate. It's a very important mineral economically. It's used a lot in construction. About 100 tons of the stuff goes into the average modern home that is built, mainly in the form of dry walls like that. We also see buried microbial mats, and we'll come back to those in a minute. So carrying on, there's that gypsum. That's what that gypsum looks like in the subsurface. You see this sediment, and within the sediment, we have these little crystals of gypsum glowing. That's because water is moving through the subsurface, groundwater, and Gary showed us that groundwater in the desert. That groundwater is moving in the subsurface, and then it's evaporating at the surface, and that process, it acts a bit like a pump. It pulls the water up, but as the water evaporates, it's going to leave its minerals behind. And over time, what we will find is those minerals will grow displaceively. They will push the other minerals, and they can't push them sideways. There's no room. They can only push those earlier sediments upwards, and those earlier sediments get eroded from the SABCA surface. And this is a bit like a conveyor belt. As this process continues, those sediments are removed. They're blown away, and we lose all the original sediments, and all we end up with eventually is this entire sediment column, this entire unit, this entire thickness of these gypsum, and maybe, if we're lucky, some anhydrite at the surface. This can be preserved into our geologic record, and it's a very important unit. It's a very important unit because it forms a fantastic barrier. It stops fluids moving. Once it's fully formed, it will stop fluids moving, and that includes our hydrocarbons, oil, our gas, and that's what has kept the oil and gas in the subsurface of the UAE. Well, we've carried on, sorry, down the slope there. We've gone down to the microbial mats, to this green arrow here, to the microbial mats, and this is where we see the life in the south. This is life. This is life, but perhaps not as you know it. This is life how it would have looked for most of Earth's history. For a couple of billion years, this was the dominant life on the planet. If you went back 1 billion years ago, 2 billion years ago, most life on the planet looked like this. These are microbial mats. These are microbial mats. These are microbes growing over the surface of the Sabkha, and again, forming these beautiful polygonal textures. And these are communities. This is not one kind of organism here. We have cyanobacteria, we have a few algae, we have diatoms, we have bacteria, we have viruses. There's a whole community of organisms in here. And many, many tens, if not hundreds of different organisms forming these communities. And if we cut a section through these polygonal structures, then you'll see below them these beautiful layered stromatolites. And we'll see these in our geologic record. And at the surface, we have this range of structures. We have the polygons you can see there. We have other structures, and that will depend on how often and for how long these environments are flooded. And there they are preserved in the subsurface. When we dig a hole, we look just below the Sabkha surface, we see these mats preserved in that subsurface, in the shallow subsurface, and we indeed see them in rocks. We see them in Jurassic rocks that we get our oil from, our hydrocarbons from in the UAE. We're going to continue our tour. We move down the slope a little bit further seaward. We're now in the intertidal zone. And this was mentioned earlier by John. John mentioned hard grounds. And these are hard grounds. These were hard grounds that were swept clear after Hurricane Guno a few years ago. If you all remember that massive hurricane that came through, and it removed a lot of sediment from the lagoons. And in the lagoons and in the intertidal zones, it exposed our hard grounds. Normally these are hidden by a few centimeters or a few tens of centimeters of sediment. And as John mentioned, these will cement up very quickly, and we have a wide diversity of different types of cement that form these rocks, and they are really very much recent rocks. They are rocks that are forming today. You can find bits of litter, you can find maybe the occasional Coke can fossilized into these rocks. That's how quickly they're forming. Very interesting environments. But we're going to walk through the intertidal zone. We're going to go down into the subtidal. I just want to, now I've really moved off the Sabkha, but it's a continuation. And this is the thing that I want you to understand, is that all the environments that we're talking about in all these talks today and tomorrow, all of them are part of a continuum. And if we walk from the Sabkha through the lagoons, we enter the marine system, we find these beautiful Uid shoals. And the Uid shoals we're studying, we're doing a lot of work at the moment on the Uid shoals. I was speaking to one of my PhD students earlier today on this subject. And if you've been out there on a boat, you'll see these beautiful white sand shoals, these terrifically gorgeous sands. And between the shoals and the deeper water areas here, you see these seagrass meadows. And again, these are areas where rocks are forming today. And again, they have hard grounds. And these are some of the hard grounds that we see forming in those shoals. So I've been very, very rapid there because I was told 8 to 10 minutes. So I've raced through that, but I've been showing lots of references here. Anybody wants any references, any papers, any details, just send me an email. I'm happy to share any of this material with you. But in conclusion, these are unbelievable environments. They are so important because they're so unique. The Sabkhas of the UAE are unique on the planet for understanding our ancient seas, our ancient ramps, our petroleum systems, helping us in the future through the energy challenges as we move towards net zero, a big challenge for all of humanity. They are our terrific laboratories. I'm not going to work my way through the list. I'm just going to leave it there. Thank you very much.
Thank you, Stephen, for that enticing talk and introduction on the Abu Dhabi Sabkhas. I'm personally from Dubai, and I know that Dubai also has quite a few Sabkhas as well, and would love a comparative lens into that. So our third speaker for the session is Guillermo Fries, a postdoctoral research fellow. Guillermo, whenever you're ready.
Yes, there you go. Can you see me and hear me?
Yes.
Great. So thank you, Amal, for the introduction. I'm indeed Guillermo Friis. I'm a postdoctoral researcher in the university, in the New York University here in Abu Dhabi. And for the last 3 years, I've been studying the evolutionary history and adaptive mechanisms of the mangroves of the Arabian Peninsula. In this brief talk, we are going to discuss the characteristics of the mangrove forest of the United Arab Emirates, the biodiversity that they harbor, and how relevant they are in the culture, socioeconomic, and scientific research of this young country that recently turned 50 years old. So let me see. Okay, there we go. So the first thing that we need to know about mangroves is that we call mangroves to the nearly 70 species of shrubs and trees that grow along the tropical and subtropical coasts of all around the world. So as you can see in this diversity map, most of these species inhabit the Indian and the West Pacific Oceans. And as you can see also in this picture taken by Noor Al-Mansouri here in Abu Dhabi, the mangroves inhabit what we call the intertidal habitat, which is basically the area that gets exposed and recurrently flooded during the tidal cycles. So mangroves indeed share the habitat that they occupy. They share a number of adaptations to the. Sorry, I'm getting a signal of start my video. I don't know if you're able to see me actually.
We can see your screen, but not you.
Oh, not me. Okay. Now, that's better?
Yes, we can see you now.
Okay, I'm sorry about that. So as I was saying, mangroves can share a habitat and a number of adaptations to the particular environment in which they live. But actually, mangroves can look very different in terms of how they look in the nature, and actually they may have very different evolutionary origins. So most of the mangrove species are eudicote species belonging to up to 15 different orders and families, but we have mangrove representatives in the groups of palms and even in the ferns. There is a fern that is considered a mangrove. So this is only to give you an idea about how diverse and polyphyletic this group of plants can be. So in the UAE, mangrove forests consist of monospecific stands of the gray mangrove species, this guy here, the Abyssinia marina species, which is the only naturally occurring species in the Arabian Gulf, and by far the dominant species in the entire Arabian Peninsula. This mangrove is also the mangrove species with the widest geographic distribution. As you can see in this map, they range all through the entire Indian Ocean and Pacific Ocean. And here in the UAE, as a part of the Arabian Gulf metapopulation, the mangroves occur at one of the northern limits of the species distribution. And they are also a representative of one of the harshest environments that they inhabit. About the status of the species in the country, and despite severe loss of mangrove populations during the last decades of the last century, several independent studies have documented a quite outstanding increase in the coverage of mangroves since the beginning of this century, to the point that nowadays the total area of mangroves in the UAE is estimated to be 150 square kilometers, which is great news when we take into account the levels that we had at the beginnings of the 2000s. And this is mostly thanks to the plantation and reforestation programs that have been conducted in the UAE. So as I already mentioned, mangroves of the UAE are subject to some of the most extreme environmental conditions found across their distribution. Actually, both maximum and minimum temperatures in the Gulf can be limiting for the biology of the mangroves, especially in places like the southeast of the Gulf, where the mangroves have to face ranges of temperatures that vary in 30 to 35 degrees from summer to winter. Salinity is also extremely high, unusually high in the southeast of the Arabian Gulf in the UAE. But even so, the gray mangroves have been able to successfully adapt to these environments to the point that nowadays they are the only evergreen forests of the region, and thereby they support high levels of diversity and even a number of socioeconomic activities that we are going to be seeing in the next few slides. So yeah, let's talk about the species that we can find in the mangroves of the United Arab Emirates. As ecosystem engineers, we already said it, mangroves in the UAE support highly diverse biotic communities, including arthropods, mollusks, birds, fishes, and also other plants. This is not going to be by any means an exhaustive list of the species that we can find there, but at least we can present the most representative of them for each one of these groups. So starting with the invertebrates, different biological surveys found that the UAE mangroves are particularly diverse in terms of crab taxa compared to other points of the Arabian Gulf. So up to 40 different species can be found in these mangroves, and this is cool because crabs are actually quite important as mangrove in the role of mangrove littering. This means that they play a fundamental role in the food chains of the mangrove ecosystems. Along with crabs, we can find a number of marine snails, up to 8 I've been able to find in the literature, but this is possibly an underestimate. And I wanted to make also an important case of the pollinators of the mangroves here in the UAE, but little has been done in terms of local research. There are at least 2 species, the honeybee and these fly species, that are known to be pollinators in other parts of the distribution of the mangroves. And they are present here in the UAE. So we may assume that they also are pollinators here, but we don't know for sure. That needs to be checked. Another aspect of the diversity of the mangroves that is outstanding and easy to see when you visit them is the avian fauna. There is over 60 marine bird species that can be seen in the mangroves. Some of the most remarkable or more iconic ones can be the western reef heron, obviously the greater flamingo, or any of the species of plovers that we can see foraging in the shores. We can also find forestal birds like the super beautiful colored kingfisher, for which we have endemic subspecies in Corcalba, or one of my favorites like the purple sunbird. And fishes, of course. Biological surveys conducted in mangrove lagoons, especially in Al Quwain and Ras Al Khaimah, also reveal high levels of diversity of fish species associated to this ecosystem. Most of them were juveniles, which actually supports the role of as nursery habitats that has been attributed to the mangroves. And here, in this case, including species of commercial importance as this mojarro can be, or the golden light sea bream that you can see in the slide. And to finish, the plants that you can find along the mangroves. This is a limited number of seawater tolerant plants, yet significant. Possibly the most common one is this little plant that you can see here, the Arthrocnemon macrostachyon. It's literally always along with the mangroves, every population that I visited. But there are other species that can be commented, like this one, the desert hyacinths, which is one of my favorites. Is this beautiful inflorescence that comes directly out of the sand without leaves, because it's a parasitic plant. Or for example, Salicornia europaea, which has become a highly appreciated plant in gastronomy, and it grows naturally with the mangroves of the UAE. So besides their ecosystemic and biodiversity relevance, mangroves have been historically important in different ways in the history of the UAE. In pre-industrial times, they were used for tinder and building material, feeding livestock, or even for medicinal purposes. And actually, nowadays, there is a number of metabolites that have been identified as of interest for pharmaceutical uses. We already saw that they are important for the vital cycle of several fish species of commercial interest, and they also play an important role in coastal preservation and even climate regulation, acting as carbon sinks. Perhaps where the presence of the mangroves in the UAE culture and heritage is more obvious is in their use and value for recreation and tourism, like in the case of initiatives of the Mangrove National Park or the Jubail Mangrove Park. From a scientific perspective, the interest of the scientific community is the interest of the scientific community in the mangroves of the Arabian Peninsula has been growing exponentially since or during the last 50 years, as we can see in these histograms of the number of publications per year, and especially in those of the Gulf. Like half of the publications in the Arabian mangroves that have been released are about mangroves of the Arabian Gulf, and from those, nearly 18% of them are based in mangroves of the United Arab Emirates. To contribute to this building knowledge, in our lab, we studied the mangroves of the UAE in the geographic context of the entire Arabian Peninsula, for which we have conducted extensive sampling for DNA sequencing and also for phenotypic analysis, as you can see in the pictures. Just as a tease, I can tell you that based on the collected samples, we have been able to among other things, reconstruct the evolutionary relationships of the mangroves of the UAE in relation with the rest of the mangroves of lineages in the Arabian Peninsula. And these and other findings will be reported in a publication that hopefully will be released in the next few months, including, for example, things like how glacial cycles affect the demography of the mangroves in the Arabian Peninsula, or what genes are involved in their adaptation to the local climate. So stay tuned for more cool stuff about the mangroves of the UAE in the next few months. Thank you.
Thank you, Guillermo, for the overview on mangroves, from their increase in quantity in 2002 to the range of species that rely on them. Next, we have Daniel Mateos Molina, who will be speaking on coastal lagoons.
Hello, everyone. I hope everything goes well in terms of technology. Let's see. Well, my name is Daniel Mateos Molina. I work for Emirates Nature WWF. At Emirates Nature, I started 5 years ago when I arrived to the UAE, developing the first habitat map for the Northern Emirates. And after that, we were expanding some efforts in identifying areas of particular importance for marine biodiversity in the UAE. So we have compiled a lot of information and identified those areas, and coastal lagoons are one of those areas. So they are now part of our main interest, especially with a new project that we are running for the next 4 years, where we are going to explore nature-based solutions for climate, biodiversity, and people on specific coastal lagoons. So on my first slide, what I would like is to make sure that we are all in the same page. We understand how a coastal lagoon is defined. Here in the UAE, they are also called cores. Those coastal lagoons are defined as shallow marine water bodies separated by the ocean by a barrier that most of the time is sand, but we can use the word of sediment deposition. And we need to thank the coral reefs that are at the front of this barrier that protect and make able to create this barrier. So this is the key of this lagoon, right? Because if not, it will be a bay. So we need to thank this lagoon and those coral reefs. And we know that in the future, probably we don't know what is going to happen if we lose those coral reefs that protect this barrier. So we will discuss later about the dynamic of those coastal lagoons. So another principle that we need to understand is that they are connected to the open sea by shallow and narrow tidal channels. That means that they have limited connection with the open sea that gives them the extreme seawater temperature and salinity that can be reached inside of the coastal lagoons. And that gives some special features that make unique the species that are able to survive on these conditions. So when we talk about the uniqueness of this ecosystem or of these systems, we need to really emphasize on the idea on the heterogeneity of of the habitats that and species that we are going to find in a small area. So we need to also emphasize in terms of the topography, of the heterogeneity of the topography, how these coastal lagoons are evolving on time, the tidal regime, and also those benthic communities that are able to survive to those extreme conditions, especially in summertime, or even we can consider summer and winter, because the idea is like they will be able to survive on those extremes, for those extreme changes. And of course, we need to acknowledge the transitional nature of the coastal lagoons. That what we are seeing here is like 4 different coastal lagoons along the coastline of the UAE, on Ras Al Khaimah, Al Quoin, Abu Dhabi, where they have been changing all the time, and we know that the sea level will also continue changing the geomorphology of those lagoons. Let me see. So coastal lagoons in the UAE are located in the intertidal zone along both coasts of the UAE, primarily in the low-lying Arabian Gulf Coast. But also we have a good representation in Sharjah, in the East Coast with Kalba. The larger coastal lagoon can be found in the southern Gulf, where in Abu Dhabi waters, with Khor Farida and Khor Bagal complex, creating like 400 kilometers square of surface, with covering the surface. And in the Northern Emirates, the largest, it will be Al Quoin, with approximately 127 kilometers square. We can find other smaller coastal lagoons in Ras Al Khaimah or even in Dubai, but those are the most, those that we are seeing here are the most representative and larger in extension. With this picture, I think it represents what we really want, or the uniqueness of these systems. We are seeing a bunch of colors that on this map of Al Quoin, each color represent a different habitat, so we can understand the complexity of multiple habitats coexisting in one place. All of them are connected, and we need to understand that as all of those are connected, all of those are helping each other. So recent studies has been now demonstrating that mangroves are more efficient or provide more services when they are close to seagrasses, or corals the same, coral reefs the same with seagrasses. So we need to understand this coastal lagoon as a whole, more than the sum of the individual habitats. And there is also other studies where they found the flux, the chemical flux between the different ecosystem, the different habitats that can be present on coastal lagoons. And of course, when we have different habitats, we have different species using those habitats. We have vulnerable and endangered and critically endangered birds using the different mudflats and mangroves in these areas. We have also sea turtles using those areas as a feeding ground. We have even the guitarfish using the sand and muddy flat and muds on those areas, and even sharks, as we are going to see in the next picture. We have shark coexisting with the different, with rays. At the same time, we have coral reefs. So it's a mix that is very important for the ecology of multiple species. So nesting and roosting area for birds. We can see here also the nesting area for the cormorants in Al Quoin, foraging area for green turtles. We're seeing one aerial image of one coastal lagoon where turtles are feeding in a massive number. Nursery areas for commercial fish species and elasmobranchs. We have been seeing different rays and baby rays coming with the large sizes. coming together and using those the coastal lagoons. So there is a lot of research now the Emirates Nature is doing in collaboration with American University of Sharjah regarding how the coastal lagoons and the different services that the coastal lagoons are providing to the species. A big point, and now it's very important to highlight because now it's growing the attention around those areas, is the socioeconomic value of these important areas. From many different point of views, we can think about the food security, where we are also talking about the fisheries. So we are seeing now also a growth in terms of a small business growing in terms of, for example, oyster farming inside of the lagoons. So we know that there is also now a lot of innovative and sustainable business around those areas, where we are thinking of, for example, about carbon credits as one of those that are now highlighted. Also, a lot of opportunities in terms of ecotourism. We are seeing now the big boom of glamping around those areas, kayaking and bird watching. But also we have been seeing a lot of interest, and especially because there were many human settlements coming from the 6,500 before Christ happening there. So now there is archaeological areas where there is a huge interest to visit, and there is a lot of tourists that they want to visit, as well as enjoying the beauty of being there. And I think we are also now appreciating more the value of spending time in front of the sea as part of the health and well-being. So we are seeing those value. And also another concept that we are seeing is that around those areas, there is always a lot of opportunities for research and education. So we see this as an important areas for the society to preserve. And my last slide is just to talk about this, the race of the conservation of those areas, especially because those areas host threatened and commercial species. Also because there is now a big emphasis from the different international and national conventions in terms of blue carbon habitats, those habitats like seagrasses, mangroves, mudflats that store and sequester CO2 from the atmosphere, and they help us to combat the climate change. So this is something that now is helping to conserve these coastal lagoons. Also, another point is the importance of the fisheries and food security for the country. We are seeing these areas that are very important as a nursery and also as a tourism spot. And we are seeing that the coastal lagoons are now recognized, most of them are recognized as an important bird areas. 4 of them has been already designated as a Ramsar sites. And 4 of them are also partially marine protected areas. So it is important to see the growth of this conservation and protection of these areas. And we hope and we anticipate that in the near future, we will see more increase in the number of protected areas and Ramsar sites that will help to manage those areas to make efficient and sustainable use of them. And that was my last slide.
Wonderful. I think your point on the coexistence of multiple habitats in a coastal lagoon really ties up the session well. We will now open to Q&A. There's a few questions. To Guillermo, one of the attendees has mentioned, they want to know, how old are mangroves in the UAE? When did they appear? And how do you measure their lifespan? Guillermo, are you with us?
He is with us, but his microphone appears not to be working. So maybe skip to.
Okay. Yeah, no worries. There's a question to Stephen. Are sabkhas a fully endemic environment in the Gulf, or can we find similar instances elsewhere in the world?
Okay, that's something I should have explained. What we have in the on the southern shore of the Gulf are the best, the biggest sabkhas, and they extend all the way from pretty much from Saudi Arabia in the northwest, right down all the way down to Ras Al Khaimah, so right across Saudi Arabia, up around the Qatar Peninsula, and then along the United Arab Emirates coastline. Now, around the world today, there's coastal sabkhas, which are different to the inland sabkhas that Gary was talking about. Coastal sabkhas are found in around about 16 places on the planet today, but none of them are as extensive or as well developed or come anywhere near in terms of preservation, quality, size, or anything to those Arabian Gulf sabkhas. So what we have is something that is unique and needs to be preserved. I'm pretty passionate about that. It needs to be preserved. It is a unique laboratory, and if we lose it, it would be a shame to lose this ecosystem. But we'd lose something we can never recreate, we can never get back. I hope that answers the question.
Wonderful, in detail. This is a question to Gary. Are invasive species a problem in the UAE?
Are invasive species a problem in the UAE? I'm certain that there would be a diversity of opinion among naturalists about that, based on their particular interests and their focus. The invasive species are certainly a potential problem. Have they become an actual problem? In natural environments of the UAE, with one or two exceptions, I would say that they have not become an actual problem. That's partly a testimony to the rigors of the UAE environment. For many years, up to the present, most botanists seem to agree that the only invasive plant that has become a problem, the only plant that's become invasive in natural areas, is the mesquite tree, Prosopis juliflora. And that, unfortunately, was so successful that it's gotten to every place that it can succeed, and therefore has eventually stopped. So it's now naturalized. That doesn't mean that we don't have to watch out. I find it a matter of concern when I see landscapers and even landscaping on government property, government properties, using desert-oriented species, for example, the cactuses from North America, using those as UAE landscaping, because being desert organisms, they have the potential to escape, but they haven't done so yet. The same prickly pear cactus that has colonized the Mediterranean is in the UAE, but doesn't seem to be getting away from perianthropic and near people environments. For animals, even some worldwide invasives don't seem to have taken off in natural areas. Best example being tilapia, the fish. Yeah.
Thank you. I appreciate that. We have one final question. I think Guillermo has fixed his mic. Guillermo, there was a question on how old are mangroves in the UAE and how do you measure their lifespan? Appreciate it. Thank you.
Oh, unfortunately, Guillermo, your microphone's still not working. Maybe we can answer it in the chat afterwards. I'll hand it back to you, Amal.
Thank you. I think such thrilling presentations, honestly, such a pleasure. This concludes our second session of today, and I'll hand it back to Nisreen, actually, your third moderator.
Thank you, Amal. Thanks, everyone. And thank you all for sticking around for our final session of the evening. My name is Nisreen Zahlawi, and it's my pleasure to be your moderator for this last session on underwater ecosystems. Just a little bit about me. I currently work at the Environment Agency Abu Dhabi on biodiversity policies and regulations. And most recently, we've had a project trying to protect the precious terrestrial ecosystems you've just heard about with the Grazing Law 11 of 2020 for Abu Dhabi announced last year. I also previously volunteered with the Emirates Natural History Group as the co-chair. And I can't think of a better way to celebrate the UAE's 50th National Day than with this wonderful series of talks on the unique and interesting ecosystems of the United Arab Emirates. So as with the previous sessions, we'll have a Q&A at the end. We'll have 4 speakers talking about the underwater ecosystems: Noor Al-Mansouri, David John Burt, and Yvonne Bejarano. And we'll start with Noor Al-Mansouri talking to us about the wonderful seagrass ecosystems of the United Arab Emirates. Over to you, Noora.
Sorry, just give me a sec. Hello, everyone. Thank you, Nisreen, for the introduction. I'll be talking today about the seagrasses of the United Arab Emirates. My name is Noora, and I'm a research assistant with Dr. John Burt at the New York University of Abu Dhabi. I'm also a PhD candidate, and I'm into my last year of my research, and where I'm studying seagrass ecophysiology, most specifically in Abu Dhabi waters. But I have a bit of an idea and background of the seagrasses in the UAE. And we've prepared this presentation with Dr. Himan Sudas of the Environment Agency. So the outline of my presentation will be as follows. I'll talk about the distribution of the seagrasses in the UAE. I'll go through the diversity of species that we have. I'll also talk about the ecosystem importance and the management conservation efforts that's currently underway in the country. So basically, we moved from the shorelines of the UAE, and now we're going to go into much deeper waters of the UAE. Just to start off, I just want to emphasize on the difference between algae and seagrass. So seagrasses are flowering, and they're closely related to land plants, and they're in a separate kingdom of algae. So algae is in a totally different kingdom than seagrasses. Seagrasses are characterized by rhizomes and roots, which they use to stabilize into the sediment, while algae, I won't go into details, but they use a holdfast to cure themselves. Seagrasses also have flowers and seeds that they produce during their life cycles. And I'll go into a bit more details on how they do that, but not into the biology of it. So global distribution of seagrass, they occur everywhere along the coastlines of every continent in the earth, from tropical to subtropical to temperate waters. So even up north here, you have cold water seagrass that exist in large meadows, and they're significantly different than tropical seagrasses. But even though there are 60 species worldwide that are currently known, only 3 of them can be found in the Arabian Gulf, especially in the United Arab Emirates. So this map here has been produced by Demeteos, who previously was talking about the coastal lagoons. And it's a very important map for me, because it tells me exactly where the seagrasses are in the Arabian Gulf, especially in the coastlines of the UAE. The study was published this year, and it specifically maps where the seagrasses are located in the coastline. And marine protected areas protect 55% of the total seagrass extent in the UAE. And you can see these seagrass species over here. But more specifically, the Marine Murawah Biosphere Reserve in the western region of Abu Dhabi constitutes 30% of the seagrass cover in the whole coastline of the UAE. Dubai Jabal Ali reserve also has a really good seagrass reserve. And you can see some along the coastlines of Ras Al Khaimah to Al Qiwain as well. So in the UAE, we have the narrow-leaf seagrass, the broadleaf seagrass, and the oval-leaf seagrass. Most of the seagrass beds here are dominated by the narrow-leaf seagrass, which is the Halodule uninervis, but you can also find the Stipulacea and the Ovalis as well. So in the study done by Lamine and colleagues in 2020, the estimate of seagrass cover in the UAE itself was around 1,400 kilometers square. And I was interested in to know like what is the length of the UAE coastline, and it's almost 1,300. So that basically means that almost all of UAE's coastline is covered in seagrass. And because it's the interface between land and sea, so you have the mangroves first, and then you have the coastal lagoons where sometimes seagrasses occur as well. But everywhere you go on the coastline of the UAE, you'll find seagrasses washed up on the shore, which indicates that there's seagrass bed nearby. Moving on to the ecosystem importance. So seagrasses are important for fisheries productivity and food security, which basically means that fish use these habitats as a spot for spawning and reproduction. And these fish that use these habitats are commercially important fish that we use for our food security. They're also important for shrimp and fisheries species. They also host a wide range of biota, such as worms and snails, and I won't get into the details of the biota, but you can see the fish here. This is a filefish that we spotted during one of our surveys. In terms of its ecological importance is the coastal stabilization. So because of the storm surges that we have frequently, the roots of the seagrass, the extensive roots of the seagrasses here, help stabilize the sediment by holding the sand and the mud together, which reduces the shift of the sand into the land. Another important thing is that they are important nutrient and carbon cycle. They're important for nutrient trapping into the sediment and carbon cycling. So they act as filters in the water column for whenever there is sedimentation happening because of storm surges. And I think last but not least, the importance of the dugongs, which I think most people know about, is that we have the 40% of the world's second largest population of dugongs just in Abu Dhabi alone, and they're classified as vulnerable to extinction by the International Union Convention of Conservation of Nature. Dugongs eat seagrasses as the only food for their diet. So that's also considered as important. They're also important foraging areas for the endangered green turtles. So even though they have other food in their diet, but seagrass areas are also important for them. Sorry. So in terms of management and conservation, the most important thing is establishing marine protected areas, and that's been widely done. Restoration activities are being explored by many government bodies and researchers, but there is no active restoration at the moment that is known to us. But more importantly is the environmental impact assessments that developers need to submit to the government bodies so that we can protect these areas from development and dredging. And it's under the laws 23 and 24 of the 1999 federal law that corals, seagrass, and mangroves are critical habitats that are protected. Last but not least, education and awareness programs that include stakeholder engagement is also important. And conferences like this sheds a light on the important habitats that we have in our beautiful country. I just want to take you through a virtual tour of what it looks like to swim in an underwater meadow. And this was taken in Abu Dhabi. I just want you to enjoy this clip of what the fish looks at when it swims between seagrass beds. And this is how diverse the seagrass beds look like. So you can see algae over here and sponges in between the seagrasses. Unfortunately, there's no fish swimming here because I probably scared them off. But this is what it usually looks like. It's green, it's lush, it's really beautiful, and most of the time it's clear. This is also another clip that can show you what kind of animals live on seagrass beds. So this is a mixed patch of seagrass and algae. Mostly algae, but I can assure you that there is seagrass intermixed with this. And this is a stingray that's swimming just like strolling through the seagrass looking for food in between the seagrass beds. Last but not least, thank you for listening. I hope this was a good timing. And I just want to show you this beautiful island and rock formation that my friend Amna Mansouri took of. This was located in Abu Dhabi next to mangroves, and it kind of represents the UAE. It looks like the UAE map in a way. Yeah, thank you for listening.
Thank you, Noura. What a great presentation, beautiful videos and footage, and a great last shot of the island. Thank you so much for taking us through the importance of seagrass ecosystems in the UAE, and hopefully more and more will be done for their protection, especially with your upcoming research and PhD on these ecosystems. Thanks again. Again, if you have any questions for Noura, we'll be able to answer them at the end of this session. Please feel free to put them in the Q&A chat box. We now move on to David John from the London Natural History Museum, who will be talking about the seaweed ecosystems of the UAE. Over to you, David.
Hello, I'm David John. I'm from the Natural History Museum in London, and I'm going to talk today about the seaweed ecosystems of Abu Dhabi, but not just Abu Dhabi. And I mentioned Abu Dhabi because that's got the seaweeds actually require hard surfaces for establishment. And actually, most of the best surfaces for establishment just happen to be in Abu Dhabi. But anywhere where there's a surface for seaweeds to grow on, hard surfaces, you'll find them anywhere along your coast. Seaweeds actually are probably the most neglected group of organisms you're going to be talking about over this next few days. In fact, when I first came to Abu Dhabi, I think in 1990, there were only 3 seaweeds that had been recorded. 1 seaweed and what was then about 2 cyanobacteria. So in this talk, I'm going to talk about seaweeds because seaweeds are benthic macroalgae, and cyanobacteria used to be called blue-green algae, but they're now known to be more closely related to bacteria, but they're called cyanobacteria. But even though many people who actually look to map the sort of beds of inshore and offshore in Abu Dhabi call them algal mats, these are still cyanobacteria, but I'll only briefly consider them. I'm going to talk about underwater habitats, as this is the session called, but the intertidal part of the underwater habitat. This is the intertidal where it's partly underwater, so it's not completely underwater. Then I'm going to consider the subtitle, talk about seasonality was incredibly important in terms of when it comes to seaweeds. Talk a little bit about interactions, about invasive seaweeds and the future. Okay, seaweeds. If you go down to the seashore and you're walking down at low tide, you'll often see the green seaweeds, and they're green because they have chlorophyll, so they're easy to recognize. So that's one of the major groups of seaweeds. To show you a few pictures of the different groups. Now, the green seaweeds, some of them, most of them are attached, as I said, seaweeds are, but there are just a few that can creep through sand, actually, and some of them are actually mixed in with seagrass beds. So you can get some which are creeping through sand and are not attached. Brown seaweeds, these are very important in Abu Dhabi. They form underwater forests, which I'll come on to talk about in a minute. Some of them are quite attractive. Unfortunately, seaweeds don't usually have common names, except one in the middle here, which is called the peacock weed, because you can see it's like a peacock tail. But otherwise, I'm afraid most of them are Latin names. But these do feel, some of these form underwater forests, which are probably very important and often quite neglected. The red seaweeds are the most important group in terms of number. They're the most diverse. And this just shows you a selection of red seaweeds. Some of them form crusts. Some of them actually are integrated with lime and are very hard, called crustose coralline seaweeds. Many of them are very bushy, and some of them are very attractive indeed. There is this other group I mentioned, which used to be called the blue-green algae, now more commonly called the blue-green bacteria or the cyanobacteria. I'll just show you a few examples here. These are all microscopic in size, but they tend to grow clumped together to form little mats and sometimes little colonies. Just looking at the numbers, the cyanobacteria, they're probably the most neglected group in the United Arab Emirates. 30 species have been recorded, but they've been very little investigated. Green seaweeds, 22 in number, brown seaweeds, 31. Then the red seaweeds are the most diverse of all. So in Abu Dhabi and the rest of the Emirates, we've got about 123 seaweeds recorded. But as I said before, just before, I'll first of all start there are often formed zones. Those at the upper zone, parts of the shore, have to be very resistant to the very inhospitable conditions we have along the coastline, a very arid coastline. So it's right at the top of the shore, you get often a dark colored band. These are the cyanobacteria. They don't seem to mind this very inhospitable environments. Lower down, you often get a zone of barnacles and other animal groups. But right at the bottom, that's where you get most of the larger seaweeds. This is showing you a picture again in Abu Dhabi at NYUAD. And if you've got tide pools, then you get quite a nice development of seaweeds, often seaweeds which occurred subtidally, you'll find in the tide pools. But the lower shore is where you're going to find the greatest diversity and biomass of seaweed, especially confined to the pools. I just show you a few examples of the algae you'll find. Of course, if you go to Fujairah, the shores are very different. We heard about this earlier, about these oolites, very hard rocks actually, and the shores are quite dramatic. You've got lots of headlands which they're almost vertical, and if you look at these headlands again, with as we mentioned before, that the shores here are very wave exposed. Many of those in Abu Dhabi, and here you get zones of organisms, and at the lower zone you've got this crustose coralline algae, these very hard algae, and often you get a little turf or soft mat of algae growing over them as well. This is the sort of thing you might see on breakwaters along the UAE coast. And the exposed spider breakwaters, they tend to be dominated by animals, and certainly seaweeds are not very conspicuous. And in Fujairah, because it's very exposed, platforms you get in front of the cliffs are often gently sloping, but because of wave exposure, you've got and a lot of sand nearby, they're very abraded. You do see algae growing over them, but it's just a very fine turf of algae, of red algae and green algae. You obviously, where you get muddy areas in Abu Dhabi, we're talking about Sabkha. Stephen was talking about Sabkha earlier on, actually, and we've been talking about mangroves. You do get some algae which are not attached, and these are mostly the cyanobacteria. So you can get mats of cyanobacteria. So here you can get little pyramidal colonies. Different species of cyanobacteria make up some of these mats. And Stephen was talking about mats having different physical features relating to the environment which these mats are formed. Quite often, it's not only just the environment, but often because of the environment, you get different species of cyanobacteria actually forming those mats. Really, one of the more conspicuous algae associated with the mangrove Avicennia are little sort of green threads of Chaetomorpha, and that's quite common. And there's a few algae you'll actually find associated with the mats or with the mangroves. Now, often when you go down to the coast at certain times of year, but more especially really between about April and May time, you find huge amounts of seaweed washed up in the shore. And this is an indication that close by there are large populations of seaweed during subtidally. And to show you where the best development of seaweed tends to be, and that is on where you've got rocky platforms gently sloping into the sea, often bordering the seaward side of shoals or on islands along the coast of Abu Dhabi in particular. Often you'll get a band of seaweed formed here during the winter time. You'll often get forests of seaweed formed here, mostly of brown algae. Just below this forest of seaweed, you get rocks I call low relief. Some of these rocks actually are probably these hard grounds that have been formed fairly recently. Behind those, you'll get sandy areas, mixture of rock and sand. Because
So it appears that David's internet is unstable. We'll give him another few seconds to see if he reconnects. It appears that we have lost David, so perhaps we can move on, Nisreen.
Okay, John, sure. In that case, John, I'll hand over to you for the next talk of this session. And John Burt, of course, from NYUAD, will be talking about the coral reefs of the United Arab Emirates.
Thank you very much, Nisreen. All right, so I'm the second to last talk, the penultimate talk, and I'm going to be talking about these beautiful ecosystems that you can see on your screen here, are gorgeous coral reefs. So just to give you an understanding of the distribution of coral reefs around the world, similar to what Noura was talking about, you can see that they're spanning the tropics basically. So they run from functionally 30 degrees north to 30 degrees south, really sitting in that band between the Tropic of Cancer and the Tropic of Capricorn. And these are obviously important for providing all sorts of goods and services to coastal communities around the world. And it's estimated that they're in excess of $500 billion per year in importance to humanity, on top of being biologically important. So that if you look at this, they only cover less than a single % of the world's surface areas, but they contain 25% of all marine species on Earth. So obviously a very important ecosystem. When you look at the area that we're sitting in northeastern Arabia, basically we're sitting right at the margins of their distribution. So you can't get much higher in latitude here before they basically disappear. And so the environmental conditions that we have here in this region really are something that can constrain coral growth. And we'll see evidence of that in the next couple of slides. So if you look around the region, you can see we've got lots of coral reef that's in the Red Sea, which is its own unique biogeographic province, as well as over around the UAE coast through the Gulf and into the Gulf of Oman and down into the Arabian Sea. This region here actually contains 6% of the area of coral reefs around the world. So they are incredibly important in terms of providing habitat for reef-associated species, for example, as well as supporting coastal communities with fisheries. And the species that we get in this region around the UAE are basically a biogeographic subset of what you get in the wider Indian Ocean. So it's much less diverse than we get over there throughout the Indian Ocean, but for reasons that are quite obvious from the environmental conditions we've talked about here. So you can see as you move northward through the region, so in the Red Sea, which is quite a large sea, you can see we have 346 species of corals. We've got the mixture of African and Indian Ocean species around Socotra, where we have around 253 species. And you can see as we move northwards, the number of species declines down to 140 in the Sea of Oman, down to 68 in the Gulf itself, again, reflecting those environmental conditions. And so the Gulf itself has a very depauperate set of the species that are in the wider Indo-Pacific, only about 10%. But those species that do occur here are remarkably robust relative to what we get in other parts of the world to environmental tolerance. And so when you look around the Gulf, all 7 nations that are bordering the Gulf contain coral reefs, including even Iraq, only discovered about a decade ago. And the UAE itself contains just over 130 kilometers of reefs, most of which, around 60% of which occurs in Abu Dhabi because of the hard bottom ground that we just heard about from David John. And these reefs do occur in all 7 of the Emirates that we have here. The only one that's a bit weird now is Dubai, which has lost all of its natural reefs as a result of coastal development. So they did occur there historically. I've dove on them myself in the mid-2000s, but they no longer occur along the coastline of Dubai, except on artificial infrastructure like breakwaters. Now, the reefs that we have in the UAE are not what we would define as true reefs, where they basically grow on top of one another through time, kind of like the Maldives, if you want to think of an example. Basically, these only occur as what we call a coral carpet. So you'll see corals growing on this rocky substrate that sort of emerges out of the sandy surroundings, and it grows as a single layer. And when a colony dies, another colony doesn't typically grow on top of it. It'll get sloughed off during storms, and then you'll get regrowth on the hard bottom itself. As you move from the Sea of Oman and into the Gulf itself and along the coast of the UAE, you can see there's significant declines in diversity. So we have approximately 60 species out in the Sea of Oman on that very small stretch of coast that's on the UAE. There's much more through the whole Sea of Oman. But as you turn the corner and you hit Ras Al Khaimah, it drops to 40. Around Dubai, Abu Dhabi border, you'd have around 30 species. And once you get to the western region towards the border of Qatar, you're talking 20 species or even less. I've dove on reefs down in the western region where there's 1 to 3 species, depending on the depth in those areas. And just to give you some pictures of what these regions look like, when you're on the East Coast, you've got extensive thickets of corals. You can see that these are often branching corals. We call these table corals or acropora, and supporting dense communities of fishes. As soon as you turn that corner and you come into the Gulf, you see dramatic changes right away. So you still see table corals around, but they tend to be much less represented. Still relatively high diversity though. So this coral that you can see over here, this species of coral, Stylophora, doesn't occur elsewhere in the UAE except on the East Coast and up towards Ras Al Khaimah. It basically disappears as you move further westward. And you're starting to see the emergence of dominance in ones that we call brain corals, because if you look at them up close, they look a bit like brains. And so as you move from Ras Al Khaimah towards Abu Dhabi, you can see these brain corals become much, much more common and are basically starting to dominate the assemblages that are here, as you can see. And these can be much lower in diversity. As I said, there's around 40 species of corals would be on a typical reef here, but you can see that the amount of coral is actually quite extensive. So they can grow quite densely, even though the diversity has dropped. As you move further westward, so this is around Saadiyat Island, towards the Bia, you'll start to see the brain corals starting to drop off and what we call mound corals or finger corals starting to appear in dominance. So these ones are typically very stress resistant. They're able to tolerate extreme environmental conditions, and they become much more common as you move towards the western region where our conditions become most extreme. And once you get to central Abu Dhabi, you can see that basically the reef is entirely dominated by those finger corals and mound corals I was talking about. And in this picture, this is basically all one single species of coral dominating that area as a monospecific stand. When you get to the far western region where it's extremely salty and extremely hot, this is typically what you'll see. You may get former reef habitat, but not with a lot of live coral on it. You'll just get occasional patches of coral that are still alive and an older remnant of a reef framework in place. However, within the Gulf, you do get areas with these large Acropora stands as well. So this is Sir Bonaire Island, which is owned by Sharjah and sits out in the middle of the Gulf, almost on the border of the international waters. And it does contain extensive stands of these table corals as well. And the reason is it's surrounded by deeper, cooler water. It doesn't have the salinity nor the temperature extremes that we get in the coastal environments that are really affecting the coral species that we see there. And so, as I mentioned, this is these temperature extremes are basically because of the shallow depth of the Southern Gulf. And, you know, we focus on the heat, but it's not just the heat. We also have one of the coolest environments for coral reefs on Earth here in the UAE, and it really does constrain corals. So temperature and salinity and these other environmental extremes do constrain the diversity of corals that we have on our reefs in the UAE, but those that do exist here are basically super corals. And so, you know, we look at the UAE as researchers as a natural laboratory to try and understand how corals can basically cope with these extreme conditions. And it's a perfect natural lab because you've got the extreme conditions of the Southern Gulf over here, and just a few hours away in a car, you're in Fujairah where conditions are normal oceanic conditions. And so for us, the UAE reefs really represent an asset for science. And we've seen rapid growth in the amount of research that's gone on in this region. This is actually only going up to 2012. If we extended it out, it would almost go straight up, the amount of publications that have been coming out on UAE reefs, because people are using them as a location to try and understand what climate change is going to do in other parts of the world, because we're projecting these conditions we get here every summer for the rest of the tropics at the end of the century. And this makes the UAE one of the best studied nations in the region for coral reef research. We also know that the Gulf is young and that corals basically colonized it quite recently. So a paper that we've got coming out very soon, we've done some genomics work on this species of brain coral here, and we know that basically as the Gulf flooded, corals came in with it, and it colonized the coastline of the UAE over here as one of the final stages of this colonization. So they've only been in this on the modern coastlines that we have here for around 6,000 years. Not a heck of a lot of time for adaptation to occur, but we do know from our genomics work that they are a distinct population of corals in here versus everything that's outside of the UAE. And this shift in the genome happened basically at the same time that the Gulf was flooded. So it started flooding, the conditions were extreme right away, and natural selection started working on these. And it basically gave these species very enhanced coral tolerance, thermal tolerance. And so we're going from 27 degrees, which is quite cool, to 33 degrees Celsius, which is Indian Ocean summer, to Gulf summer, 36 degrees Celsius. For the larvae, you can see at 27, the survivorship of Gulf of Oman, which is in blue, and Arabian Gulf coral larvae is basically the same through time. But when you start increasing the temperature, you can notice that the Gulf of Oman species are really dropping out in terms of their performance. So the survivorship really drops in the Gulf of Oman species. Similarly, in the adults, you can see they're basically identical at 27 and 33, but then there's a huge difference in the survivorship at 36 degrees Celsius. And this is basically leading to an upwards of 1/3 to 1/2 increase in survivorship if you were born in the Arabian Gulf versus out in the Sea of Oman when you hit that 36 degrees Celsius temperature. And this basically gives the corals here the highest thermal tolerance that we know for the entire world. So they can survive temperatures of up to 35, 36 degrees Celsius for over several weeks, whereas corals from the Great Barrier Reef or the Caribbean, basically if you expose them to even 32.5 degrees Celsius, they die immediately. And so these really are super tolerant corals. We've even done experiments where we've taken corals from the Gulf, we've collected their larvae, taken the sperm and the eggs from those larvae and crossed them with the gametes from the Indian Ocean corals. And we looked at what is the result of these offspring if they're Gulf only, if they're Indian Ocean only, or if we cross them at these different temperatures. And what we see is there's a huge increase in survivorship of the crossed offspring, meaning that we can take these thermal tolerance genes and put them into corals from other parts of the world as a potential mitigation strategy for climate change down the road. So this really is an interesting system to work on. What's going to happen with it in the future? Well, the Gulf is actually, Nazreen, how much time do I have left?
You have about 2 minutes, John.
Thank you. So the Gulf is actually warming at roughly twice the global average. So we're seeing an increase of around 0.5 degrees Celsius per decade. And you can see that that's a lot larger than the rest of the Indian Ocean if you're looking at either the East Coast or the West Coast of the UAE. And I've taken data from Zuhair Lakhar, who's one of my colleagues here at NYU, and we've tracked data on sea surface temperatures. So the flat line represents 0, the average from 1982 until 2011. And what you can see is before sort of the 1990s, we were below that average, and we've been trending up above that average for the last decade and a half or 2 decades. And so the seas here are getting warmer. Yes, there's variability from year to year, but you can see that there's an obvious trend through this data. And the question becomes, you know, what's going to happen as we extend that data that we had up until 2010, up until 2050? And what you can see is not a very encouraging sign that this would actually equate with something like a 2 degrees Celsius increase in temperature on the reefs of the UAE going forward. That suggests that these reefs, which are living on the margins of tolerance right now, are probably going to start getting pushed over the edge more and more as we continue through time over the coming decades. And so we had reefs that looked like this all across the Southern Gulf in the 1990s. Today, they look more like this, at least in the Southern Gulf portion of the UAE, and they're starting to look like this over on the East Coast, as I'll discuss in a moment. And the question is, are they all going to look like reefs in the Western region by 2050? And what are the implications of that for things that are reef associated, particularly obligate reef associated species like these 2 species of fish here, which only occur on corals and feed on corals? There is hope though. We've published a paper last year where we look not just at the genomic changes that are happening in these organisms, but also at the what's called epigenetic changes that are going on. This is where the environment interacts with the genome to allow much faster rates of, let's call it, response to environmental change. And we've shown that there is this epigenetic inheritance that's going on in corals in the UAE, which may allow a much more rapid adaptation to this changing climate. The other question becomes, you know—
John, one more last, I mean, you're over time. If you could conclude, thank you.
I will. And with that, I conclude. Thank you, Nazreen.
Okay, perfect. Thanks so much, John. Guys, we're still trying to get David back. He's having some connection issues. But in the meantime, I think we should move on to our last but not least, Dr. Yvonne Bejarano from the American University of Sharjah, who will be talking to us about oyster reefs.
All right, thank you very much, Nazreen. Good evening, everyone, and thank you for staying for the probably last presentation of tonight. My name is Yvonne Bejarano. I am an assistant professor of biology in the American University of Sharjah. I'm a marine biologist, and I have been studying marine and coastal ecosystems in the UAE for about the last 5 years. Mostly focusing on fish fish communities. I prepared this presentation with some colleagues from the American University of Sharjah, Emirates Nature, Environment and Protected Areas Authority, and the Higher College of Technology. And I'm going to be—
sorry to interrupt, we can't see your presentation. Could you try sharing your screen again?
I did. Okay, wait. How about now?
Yeah, it's there. You could
right,
just do full screen. Yeah, there you go.
Okay, all right. There you go. Thank you. Sorry for that. Yeah, so I'm going to be talking about oyster beds in the UAE. Of course, every time we talked about oyster beds, we have to travel a little bit in time because of the very important tradition that the country has with these ecosystems. And actually, oyster beds during the 19th and 20th centuries in the Arabian Gulf were actually the most valuable ecosystems. And the reason is, well, of course, because of pearl diving, right? So pearl diving was a very lucrative activity in the past, and it was for hundreds of years. And the thing is, well, the pearls from the Gulf were actually considered the finest one in the world. And of course, well, this was an amazing opportunity for local people to get some income from those oyster beds. People moved, families moved to coastal areas, and well, every day they became more dependent on these coastal ecosystems. This tradition, of course, was lost after the development of cultured pearls in Asia. And of course, many locals would say, well, of course, not same quality as the natural ones that sometimes they still find here. Okay, oyster beds as ecosystems. So the photo you're seeing there is actually one of the clearest photos we have for oyster beds here in the UAE. Oyster beds are going to be ecosystems that are formed thanks to the gathering of many oysters and the fusion of their shells. So they're going to be forming, grouping, fusing together, and they're going to be forming hard areas. Now, oyster beds distribute globally. They can be present in all different forms of waters. They can grow in cold and warm waters. They are present inshore and offshore, and they can grow in brackish or marine waters. So they're very tolerant. And one of the major things of the oyster beds or oyster reefs is that they form a barrier, right? A rigid barrier, which is important, same as coral reefs, to reduce the energy of the currents on the sea. Therefore, oyster reefs or oyster beds are barriers to waves and tides, and therefore they help prevent erosion from the coast. At the same time, what we're going to have is oyster beds creating new habitat that is going to be occupied by different species from the sea. Small species and then bigger species following or feeding on those smaller species. And at the end, humans being benefited as well by the attraction or the use of commercial species of these oyster beds. Now, despite all this great importance that have oyster beds and that have had in the past of the UAE, we actually don't have a very good understanding on the status of oyster reefs in the UAE. We know that oyster reefs distributed in the past all across the Gulf. And actually the map I'm sharing here with you, it's showing you those locations that used to be visited by pearl divers. So this knowledge was passed traditionally from generation to generation of pearl fishers. And well, this is just a map showing where we're supposed to be in the past oyster reefs across this part of the Gulf. We know that oyster beds occur from Iran to Kuwait to the UAE and to Oman. And we also know that there are some oyster beds as well on the east coast of the UAE. However, and ironically, I would say, because now we have amazing technology, right, to be able to map the distribution of oyster beds all across the Gulf. But well, we don't know, we don't have a good map that can tell us how is the status, where are those oyster beds right now in the Gulf. Emirates Nature in 2018 developed an habitat map. And that was a great opportunity for us to know where in the northern Emirates we can still find some of these oyster beds. And that is the purple areas that you can see in this map here. So once we knew that there are still some areas of oyster beds, we were very interested in knowing, well, which are the biological and environmental conditions in these oyster beds? How are they? And well, that's when we decided to go jump in the water, take some biological samples, make some censuses, drop some underwater cameras, take some sample waters of sediment samples. We analyzed the phytoplankton, and we also check for the presence of microplastics. And well, what did we found specifically for the oyster beds here in the UAE? And maybe when I share with you this photo, right, you're thinking, well, yes, I can see some oysters there or some bivalves there, but not much life, right? But the thing is, you have to make a zoom in, right? And when you get really closer, then you're gonna notice how oyster beds actually build a very important structural complexity in bottoms that otherwise would be quite plain, right? And this complexity is well used by a very, very large number of species. Like, for example, those that you can see here, right? So you can see invertebrates growing on the shells of the oysters. And you can see, for example, these little fish, well, just here, staying there. Now, that little fish is probably going to be the food, right, the meal for this quite interesting sea snake that we grab with one of our underwater videos here, and well, as part of other big fish and species that we found also associated to these oyster beds in the UAE. Well, we found some groups of fish like this one, the spine cheek, Arabian spine cheek, and we also found very important commercial species like, for example, the hamur you can see there. Now, if you notice the complexity of oyster beds here in the UAE can be quite different. So in this photo here, you can see like a plain, much less complex oyster bed compared to these two forms where you can see more than an oyster bed, well, probably what we would call an oyster reef, right, with greater complexity. In terms of invertebrates, we also found a huge diversity of species, including corals, hydroids, sea urchins, and well, many more. Now, in terms of the environmental conditions, well, we were interested to know the characteristics or the status of the water and the sediments in oyster beds. The reason is oysters are sessile filter feeders and they clean the waters that surround them. So, because they feed on the microalgae suspended in the water. So we made some assessment of the water quality in oyster beds, and we tested for heavy metals, pesticides, herbicides, microplastics, and we also were looking for the phytoplankton. We wanted to know if phytoplankton could be used as a bioindicator of environmental conditions. Our results are that, well, these oyster beds at least are going to be growing in relatively clean waters. So the levels were within the regional and global standards. And we found also positive results in terms of pesticides and hydrocarbons in sediments and also in the oyster tissue and in the water. So we conclude that there is no organic pollution in these oyster beds. In terms of phytoplankton, we found some species being more abundant in oyster beds, dinoflagellate, and we found differences in the composition and abundance of species, which means that probably we can find some bioindicators there. One particular species was suggested as a potential bioindicator of nutrient enrichment. And finally, my last slide is about microplastics. We found, of course, the presence of microplastics of different shapes, different sizes, and different colors in the sediments of these oyster beds. Thank you very much. And well, I think that's all from my side.
Thank you so much, Yvonne, for your great, interesting presentation. I think oyster reefs are really understudied in the UAE, and be fantastic to know more about them. I'm not sure if you've contacted the National Archives Department. They have great records of oral history from fishermen, traditional fishermen, talking about the uses and the locations of oyster reefs. So perhaps this is something to consider, and we're happy to help with that. So this brings us to the end of our underwater ecosystem session. Thank you all for sticking around. And we'll now, we'll have 10 minutes approximately to answer some of the questions. The first question to Noura, Ada actually was asking, what are the main threats to seagrass in UAE, and what are the actions taken to protect them aside from marine protected areas?
I think after coastal development would be climate change. So understanding the resiliences is important, and that's part of the research that I'm doing in my PhD is how these seagrasses recover after disturbance, after a disturbance event. So I think that's the next step in understanding their recovery patterns, which will help us know, like, if a storm surge or if a major climate event happens, what will happen to these seagrass beds?
Thank you, Noura. We have a question to David. I'm not sure if he's on the call. David, can you hear us?
Yeah, yes, I can.
Oh, okay, wonderful. The question is, are there any benthic diatoms within the cyanobacteria mats over the mudflats and within the mangroves?
Did you say diatoms?
Yeah.
No one's actually really looked at the diatoms. There is a list of the diatoms for Abu Dhabi, and I think it's probably about 80 or 90 diatoms have been recorded, but those were never recorded in the cyanobacterial mats. They were collected in very sheltered areas in inshore, on sort of sandy inshore areas. So I'm afraid I don't think there's any information for the mats at all. People have looked at the cyanobacteria, but only one person, Dr. Golubik, and he recorded quite a number of algae, and the mats themselves, the cyanobacterial mats, the surface varies depending on how the mats were formed, as Stephen actually has said, but the actual composition of the species varies as well. But cyanobacteria are very difficult to identify. I mean, I've had a go at them, and they are very difficult. They really require a specialist. And of course, with genomic research these days, we're coming to, I think in a few years' time, I think it will be possible to identify them using signatures or what might be called barcoding. It's happening for macroalgae as well, but it is very, very slow. There's very few sort of like dictionaries of information, which is showing unique parts of the genome for different species. It's coming, but it's slow. And for macroalgae, it is the same. And sure, for John with corals, I'm sure it's happening quite quickly. But different organisms, it's the pace of the researchers, is very variable indeed, actually. That's why in in the Gulf, we have to use morphological characters for identifying the seaweeds. And with diatoms, they are actually already working on diatoms as quite an active group, but probably freshwater diatoms as opposed to marine ones. So it's happening, things are changing. But the diatoms, no, I don't think we've got any information on those in the cyanobacterial mats.
Thank you so much, David. And actually, there's one more question. I'm not sure if you can see it, but I'll just read it out. Are only the green seaweed edible, or other seaweeds are edible? I guess this is related to the commercial uses or uses of seaweed ecosystems.
Actually, there's a lot more interest than there's been for many years in people being able to eat seaweeds. And some of the seaweeds in the Gulf, you know, you've got the elder seaweed, it's like the sea lettuce would be the common name. It's a green seaweed, and that has certainly been used to put on salads and things like that. And in fact, some of those larger brown seaweeds, you know, are probably, I think the sargassums have been used to actually feed camels in certain parts of the Middle East. So, and probably not in Abu Dhabi, but in other parts they have been used. But for humans eating them is something else. I do come from a part of the world where people do eat seaweeds occasionally down in South Wales, but you have to boil them for many hours, and it's an acquired taste. So I wouldn't necessarily recommend it, but you know, in some parts of the world, people do eat it a lot. But it's something to think about. You could experiment. Why not?
Maybe we can mix in some seagrass with that.
Oh, well, I think the seagrass, that's something else again, actually. I think some of the seaweeds might be better than seagrass. Seagrass might be better for feeding animals. You could probably dry it, and when it gets washed up in the coast, you could probably, you know, collect it. Because there's certain times of year, like the seaweed gets washed up, you know, especially really from about March, April, May time, when the seaweed's beds disappear almost offshore. The whole seascape is transformed. And that might be a time when those could be collected from the shore and possibly dried and could be fed to animals as well. You know, camels, chickens, all sorts of things. So there could be uses that seaweed could be put to. The main problem is that people collect seagrass and seaweeds along the coast because it looks unsightly. But remember, there's a whole little ecosystem there that develops where there are little creatures that eat the actual drift plants that come up from the shore. And then birds come and eat them, you know, so there's a whole sort of series of events take place. It's all part of the food chain of it. So, you know, just bear that in mind, not to remove things.
I'm not encouraging it.
Yeah. So we have a question for John. So coral reefs are, as we've just heard, under a lot of pressure. What, in your view, are what are the measures that can be taken to help conserve them?
Sure. Well, I guess before answering that question, I'd like to say, so at the end of these talks, I can't believe it, but we had something like 115 people all evening, and we had 97 at the end of Yvonne's talk. So it's amazing that everyone has stuck around, which shows how much interest there is in this fascinating system that we have here. So thank you all for staying, and I look forward to seeing you tomorrow. To answer your question, well, already the government's doing some things. So they're putting in marine protected areas. Some of this has to do with international obligations. Some of it has to do with local interest. But the MPA networks or the MPA design as it's currently set up in the UAE isn't so much structured by biology as it is by, politics or need to protect a certain area, et cetera, that doesn't necessarily have biological underpinnings. So I think that's part of the question, is figuring out, okay, is it the areas that are under the most threat that we should be conserving, or the ones that still retain the most diversity or the higher abundance? Those are some basic questions, and then start looking at, okay, can this small network of marine protected areas work as effectively as having a few very big ones, et cetera, looking at larval dispersal between units and so on and so forth. I also think that there does need to be active measures towards intervention. So we've been using very passive approaches like marine protected areas in the past, and I think restoration has to start happening. I know it's expensive, I know it takes a lot of effort, but we are losing portions of ecosystems at an alarming rate. And so I think there's conservation in conjunction with restoration activities that needs to be considered.
Thank you, John. And then just to conclude this session, we'll have a last question to Dr. Yvonne. Dr. Yvonne, you talked about pollutants and microplastics in oyster reefs. So what is the future in terms of using oyster reefs as maybe indicators or measures of environmental pollutants in the marine environment, in your view?
So I have to say that based on our results, what we found is, well, actually, we were positively surprised, right? Because these are very coastal, very close to shore. These oyster beds are very close to shore. And well, we measured these pollutants in different, so in the water, in the mussel of the oysters, and as well in the sediment. So it was an amazing surprise to see that, well, actually, there's not much contamination there. In terms of bio indicators, I think results, we are still working on the data, but apparently there is a good potential at least to use the phytoplankton for this. What we have found by now is at least some response to a little bit high concentrations in nutrients. It was measured in the water nutrients samples, but also it was detected by the presence of that particular species that I mentioned in the presentation. So I think it's something that we need to study further, but I think there is the potential, yes.
Thank you so much. Thank you. Thank you all for this great session. I'll now hand over to John for our concluding remarks, and we hope to see you all tomorrow.
Well, I don't have much to say other than thanking all of the speakers for the fantastic talks we had tonight. I really enjoyed these and learned a lot. So I appreciate you all contributing, and to the audience for sticking around. I've learned a ton. I assume you have as well, and I hope to learn more tomorrow. So please do join us at 6 p.m. tomorrow. Where we'll have a shorter session of just 2 sessions, followed by a conversation about the Emirates Natural History Group and how you might engage. Ciao.